ಕ್ವಶನ್ಸ್ ಬೀಳುತ್ತಲ್ಲ ಅದ್ರ ಮೇಲೆ ತಗೋತೇನೆ ಆಯ್ತಾ. ಸೊ ಹಾಯ್ ಎವ್ರಿವನ್, ಆಮ್ ಐ ಆಡಿಬಲ್ ಅಂಡ್ ವಿಸಿಬಲ್ ಪ್ರಾಪರ್ಲಿ ಟು ಎವ್ರಿವನ್? ಲೆಟ್ ಮೀ ಚೆಕ್ ಒನ್ಸ್. Am I visible and audible to everyone properly? Yes. Once again guys, so let me check it once. Am I audible properly to everyone? Oh, I'm not audible. Just give me 1 second. Yes, I'm audible now. Yes, I'm audible now. Yes, I'm audible now. Yes. Yes. Hi everyone. Just give me 1 second. I'll just refresh it. Okay then. Yes, audible. Okay. Let's start the class then. ಸೊ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಚಾಪ್ಟರ್ ಇಂದ ಯಾವ ತರ ಮತ್ತು ಎಷ್ಟು ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು ಅನ್ನೋದು ಫಸ್ಟ್ ನಿಮಗೆ ಹೇಳ್ತೇನೆ. ಸೊ ದಟ್ ವಿಲ್ ಹ್ಯಾವ್ ಅ ಐಡಿಯಾ ದಟ್ ಎದಕ್ಕೆ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡಬೇಕು, ಈ ಕ್ವಶನ್ಸ್ಗೆ ಈ ಚಾಪ್ಟರ್ಗೆ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡಬೇಕೋ ಇಲ್ಲೋ ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ಐಡಿಯಾನೇ ಗೊತ್ತಾಗುತ್ತೆ ಅದರಿಂದ. ಕ್ಲಿಯರ್? ಸೊ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಆಲ್ಮೋಸ್ಟ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ 3 ಕ್ವಶನ್ಸ್. ಓಕೆ, 3 ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಪ್ಲಸ್ ಇದರಿಂದ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಕೇಳ್ಬೋದು ಅಂದರೆ ದೇ ಮೈಟ್ ಆಸ್ಕ್ ಟಿಲ್ 8 ಮಾರ್ಕ್ಸ್. ಓಕೆ, ದೇ ಮೈಟ್ ಆಸ್ಕ್ ಟಿಲ್ 8 ಮಾರ್ಕ್ಸ್. ಕ್ಲಿಯರ್? ಸೊ 2 to 3 ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು, ಪ್ಲಸ್ ದೇ ಮೈಟ್ ಆಸ್ಕ್ ಇಟ್ ಫಾರ್ ದ 8 ಮಾರ್ಕ್ಸ್ ಆಲ್ಸೋ. ಕ್ಲಿಯರ್? ಕ್ಲಿಯರ್ ಎವ್ರಿವನ್? ಸೊ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಅಂದರೆ ಎಲ್ಲರಿಗೂ ಅನಿಸ್ತಿರ್ಬೇಕು, ಮ್ಯಾಮ್ ಇದು ಫಿಸಿಕ್ಸ್ನಲ್ಲಿನೂ ಇದೆ ಅಲ್ಲ ಮ್ಯಾಮ್, ಫಿಸಿಕ್ಸ್ನಲ್ಲಿನೂ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಇದೆ, ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲೂ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಇದೆ. ಎಸ್, ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಇಸ್ ಇನ್ ದ ಫಿಸಿಕ್ಸ್ ಆಲ್ಸೋ ಆ್ಯಂಡ್ ಇನ್ ದ ಕೆಮಿಸ್ಟ್ರಿ ಆಲ್ಸೋ. ಯಾಕಪ್ಪ? ಸೊ ಈಗ ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ ಕೆಮಿಕಲ್ಸ್ ಯಾವ ಥರ ರಿಯಾಕ್ಟ್ ಆಗ್ತಿದೆ, ಯಾವ ಸಿಸ್ಟಮ್ ಇದೆ, ಸೊ ಅವನ್ನೆಲ್ಲ ನೀವು ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ ಕಲಿತೀರಾ. ಫಿಸಿಕ್ಸ್ನಲ್ಲಿ ಏನು ಕಲಿತಾರೆ ಅಂದರೆ ಯಾವ ಥರ ಸಿಸ್ಟಮ್ ಆಗ್ತಿದೆ, ಯಾವ ಡಿಸ್ಟೆನ್ಸ್ನಲ್ಲಿ ಆಗ್ತಿದೆ, ಅದ್ರ ಡೆರಿವೇಶನ್ಸ್ ಏನು, ಅವೆಲ್ಲ ಅದರಲ್ಲಾಗುತ್ತೆ ಫಿಸಿಕ್ಸ್ನಲ್ಲಿ. ಆಯ್ತಾ? ಸೊ ಟುಡೇ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಅಬೌಟ್ ಸಮ್ ಡೀಟೇಲ್ ಚಾಪ್ಟರ್ ಅಬೌಟ್ ದಿಸ್. ಆಫ್ಟರ್ವರ್ಡ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ದ PYQs. ಫಸ್ಟ್ ವಿಲ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಕಂಪ್ಲೀಟ್ಲಿ ಆನ್ ದ ಥೇರಿ. ಯಾಕಂದರೆ ಥೇರಿ ಪರ್ಫೆಕ್ಟ್ ಇರಬೇಕು ಅಂದ್ರೆ ನಿಮಗೆ PYQs ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಆಯ್ತಾ? ಈಸಿಯಾಗಿ ಯಾವಾಗ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು? ವೆನ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ theory. Clear? Thermodynamics, a branch of a chemistry which gives information about the flow of a heat, which will give the information about the flow of a heat. How long the lecture is. Lecture is going to be long, like almost 2 hours tak. Okay, 2 ತಾಸು ತನ ಇರಬಹುದು. ಆಯ್ತಾ? Thermodynamics is a branch of a chemistry which gives the information about the flow of the heat. Flow of the heat means what? At what stage, what rate the heat is getting flowed. Means what? Whatever the reactions we are doing it, whether it is in the closed container, whether it is in the open container. So adralli yav tara ನಾವು heat apply ಮಾಡ್ತಿದ್ದೇವೆ, how the exothermic process is working, how the endothermic process is working, that we will learn it. Okay, like example, objects of the thermodynamics are going to be in the 4 things. Okay, first is various heat changes such as delta H, delta E and delta G. We will learn these things in the detail. Okay, next comes various thermodynamics processes. So we have few processes also. Process andre yav tara andre yav tara actually delta G is getting changed, yav tara ಆ ಸಿಸ್ಟಮ್ ಹೀಟ್ ಸಿಗ್ತಿದೆ, ಯಾವ ತರ ಆ ಸಿಸ್ಟಮ್ ದಿಂದ ಹೀಟ್ ಹೊರಗಡೆ ಬರ್ತಿದೆ, ಸೊ ಅದನ್ನೆಲ್ಲ ಇಲ್ಲಿ ಕಲಿತೇವೆ. ಓಕೆ, ವೇರಿಯಸ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೊಸೆಸ್ ನಲ್ಲಿ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವೇರಿಯಸ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಲಾಸ್ ಆರ್ ದೇರ್, ಲೈಕ್ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್, ಸೆಕೆಂಡ್ ಲಾ ಇದೆ, ಥರ್ಡ್ ಲಾ ಇದೆ. ಸೊ ದೋಸ್ ಆಲ್ ಥಿಂಗ್ಸ್ ವಿ ವಿಲ್ ಬಿ ಲರ್ನಿಂಗ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಂಡ್ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್. ಏನ್ ಬರುತ್ತೆ ನೆಕ್ಸ್ಟ್? ಸ್ಪಾಂಟೇನಿಯಸ್ ಮತ್ತೆ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್. ಸೊ ಅದನ್ನು ಡೀಟೇಲ್ ಆಗಿ ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಕಲಿಯೋದು ಆಯ್ತಾ. ಸೊ ಲೆಟ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಲಿಮಿಟೇಷನ್ಸ್ ಆಫ್ ಅ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್. ಓಕೆ, ಏನಪ್ಪ ಲಿಮಿಟೇಷನ್ಸ್ ಇದೆ ಅದರದ್ದು. ಓಕೆ, ಲಿಮಿಟೇಷನ್ಸ್ ಅದಕ್ಕೆ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ನಲ್ಲಿ ಅಂದ್ರೆ. ಸೊ ದೇರ್ ಇಸ್ ಸಮ್ ಎಕ್ಸೆಪ್ಷನಲ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್ ಆಲ್ಸೋ. ಲೈಕ್ ಹೌ ನಮಗೆ D&F ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಎಕ್ಸೆಪ್ಷನಲ್ಸ್ ಬರುತ್ತಲ್ಲ, ಅದೇ ತರ ಇಲ್ಲಿ ಎಕ್ಸೆಪ್ಷನಲ್ಸ್ ಬರುತ್ತೆ. ಕ್ಲಿಯರಾ? ಸೊ ಇಲ್ಲಿನೂ ಸ್ವಲ್ಪ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ, ಬಟ್ ಐ ವಿಲ್ ಟ್ರೈ ಟು ಮೇಕ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಬೈ ಗಿವಿಂಗ್ ದ ರಿಯಲಿಸ್ಟಿಕ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಟು ಯು. ಓಕೆ, so limitations ಏನು? does not give information about the rate of the reaction. It will not give the information about the rate of the reaction. Rate of the reaction means what? Whether that rate is going to be very slow, the reaction is going to be very fast. So ಅದು ನಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. ಕ್ಲಿಯರಾ? ಸೊ ರಿಯಾಕ್ಷನ್ ಏನೋ ಕಡಿಮೆ ಆಗ್ತಿದೇನೋ, ರಿಯಾಕ್ಷನ್ ಹೆಚ್ಚಾಗ್ತಿದೇನೋ ಅದ್ರ ಬಗ್ಗೆ ನಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. ತಿಳಿತಾ? ನೆಕ್ಸ್ಟ್, thermodynamics processes are not applicable for the microsystems such as electrons, protons and neutrons. Yes, so it is applicable for the atoms. Okay, applicable for the atoms, but it's not applicable for the electrons, protons and neutrons which are actually present in the atom. Clear? So atom nalli ಏನು electron, proton, neutron ಇದೆಯಲ್ಲ ಅದರ ಮೇಲೆ application ಆಗಲ್ಲ. Clear? Next, objective of the universe is what? System and the surrounding. This is very important to understand. ನೀವು ಯಾವಾಗ ಸಿಸ್ಟಮ್ ಮತ್ತು ಸರೌಂಡಿಂಗ್ ಬಗ್ಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಗುತ್ತಲ್ಲ ಅದರ ಪ್ರಕಾರ ಈ ಚಾಪ್ಟರ್ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಆಯ್ತಾ. ಸೊ ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಎನ್ ಸಿಸ್ಟಮ್? ಓಕೆ, ಏನಪ್ಪ ಸಿಸ್ಟಮು? ನಮ್ದು ಏನು ಮಾತಾಡ್ತಿದ್ದೇವಲ್ಲ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸು ಅವೆಲ್ಲ ಯಾವ ಸಿಸ್ಟಮ್ನಲ್ಲಿ ಆಗ್ತಿದೆ, ಯಾವ ಸಿಸ್ಟಮ್ನಲ್ಲಿ ಆ್ಯಕ್ಚುಲಿ ಅವು ಆಗಬೇಕು ಅದನ್ನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. So a part of a universe where covered with the real or imaginary boundary where we study about the various thermodynamics properties such as pressure and temperature. Okay, we are going to learn here about the pressure and a temperature. Clear? And then surroundings means what? Rest part of the universe. Okay, rest part of the universe is actually going to be what? Surrounding. Clear? System ನಲ್ಲಿ ಏನಿದೆ? The part of the universe is covered with the real or imaginary boundary. Okay, real ಮತ್ತೆ imaginary boundary ಇರುತ್ತೆ. ಆ real ಮತ್ತೆ imaginary boundary where we will study about the various thermodynamics. Various thermodynamics ಅಂದ್ರೆ like by applying the pressure ಸ್ವಲ್ಪ ಕಲಿತೇವೆ, by applying the temperature we are going to learn. According to that we are going to learn it. Clear? So let us see how the system is working and what is actually the system's boundaries. Okay, system ಏನು ಮತ್ತೆ ಅದರ ಬೌಂಡ್ರಿಗಳು ಏನು ಅನ್ನೋದು ನೋಡ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ. ಸೊ now this is a system. Clear? So ಈಗ ಒಂದು ಏನೋ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಿದೆ inside the system. Okay, the reaction is happening inside the system. Like example, this is the surrounding. Means what? System ನಲ್ಲಿ surrounding ಏನ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು doesn't matter to us. Okay, why? Because it's a closed container, right? You can see the image itself how it is closed container. ರೈಟ್. ಸೊ ಇದು ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ಆಗಿದೆ. ಅದರಲ್ಲಿ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ನಲ್ಲಿ ಯಾವ ತರ ಸಿಸ್ಟಮ್ ಎಫೆಕ್ಟ್ ಆಗೋದು ಎಲ್ಲ ಇನ್ಸೈಡ್ ಇರುತ್ತೆ. ದ ಆಲ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಇನ್ಸೈಡ್ ದ ಸಿಸ್ಟಮ್, ನಾಟ್ ಅಟ್ ದ ಔಟ್ಸೈಡ್ ದ ಸಿಸ್ಟಮ್. ಕ್ಲಿಯರ್? ಸೊ ಇಟ್ ಡಸಂಟ್ ಮ್ಯಾಟರ್ ಟು ಅಸ್ ವೆದರ್ ಇಟ್ ಇಸ್ ಇನ್ಸೈಡ್ ಆರ್ ವೆದರ್ ಇಟ್ ಇಸ್ ಔಟ್ಸೈಡ್. ಕ್ಲಿಯರ್? ಸೊ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಸಿಸ್ಟಮ್ ಬೌಂಡ್ರಿ. ದಿಸ್ ವಿಲ್ ಬಿ ವಾಟ್? ಸಿಸ್ಟಮ್ ಬೌಂಡ್ರಿ. ಇಲ್ಲಿ ಸಿಸ್ಟಮ್ ಬೌಂಡ್ರಿಯಲ್ಲಿ ಏನಾಗುತ್ತೆ? ದಿಸ್ ಇಸ್ ಅ ಸಿಸ್ಟಮ್. ಓಕೆ, ಇವೆಲ್ಲ ಸರೌಂಡಿಂಗು. ಸೊ ಇಷ್ಟರಲ್ಲಿ ಅಷ್ಟೇ ಆ ಕೆಲಸ ಆಗಬೇಕು. Okay, only in this the work needs to be done. The work will be done only in this much. Clear? Only in this much the work will be done. Okay, done? One second. Okay, understood system andre enanta. Next comes, for a system, the change in energy is identical in magnitude but opposite in sign to the change in energy of its surrounding. Change in the opposite of this surrounding. Andre, for a system, if the change is in the energy, if there is a change in the energy, then that identical is going to be the magnitude but opposite in the sign. Means what? The change in the energy of its surrounding. Means what? Naniga hogi Kashmir nalli nintidane. Okay, I am standing in the Kashmir right now. How the surrounding will be mine? temperature ಏನಿರುತ್ತೆ ನಂದು almost it will be lesser, right? 15 degrees Celsius or else 10 degrees Celsius, 8 degrees Celsius. ನನ್ನ surrounding full cold ಇದೆ. Now same thing if I go and stand in the Rajasthan, okay? ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇರುತ್ತಪ್ಪ, 35 40 ತನಕ ಹೋಗ್ಬೋದು. ಸೊ ಆ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿರುತ್ತೆ. ಸೊ ಡಿಪೆಂಡ್ಸ್ ವಾಟ್ ನನ್ನ ಸರೌಂಡಿಂಗ್ ಪ್ರಕಾರ ನಾನಿರ್ತೇನೆ. That's what the reactions are also going to happen according to the surrounding. Now in case if you are going to not refer about the surrounding, okay, then whatever the reaction is happening inside the surrounding, it is happening, okay? So inside the system it is happening. Clear? Understood? Understood? Next, types of a system. So in types of a system, thermodynamic system, first is going to be the open system where the heat transfer and mass transfer is happening. Then the closed system where the heat transfer is happening but no mass transfer is being happening. Here mass transfer, how it is happening? It's getting evaporated and it's going. Okay, it's getting evaporated and going. Means what? It is getting converted into the gaseous. Okay, gas nalli convert ಆಗ್ತಿದೆ. ಏನು liquid ಇದೆ ಅಲ್ಲ, that is converting to the gas. Clear? ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಕ್ಲೋಸ್ಡ್ ಸಿಸ್ಟಮ್ ನಲ್ಲಿ ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್, ನೋ ಮಾಸ್ ಟ್ರಾನ್ಸ್ಫರ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಬಿಕಾಸ್ ಇದು ಕ್ಲೋಸ್ ಆಗಿದೆ. ಗ್ಯಾಸ್ ಹೊರಗೆ ಬರ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಕ್ಲೋಸ್. ಇಟ್ಸ್ ಗ್ಯಾಸ್ ಇಸ್ ನಾಟ್ ಗೋನಾ ಕಮ್ ಔಟ್. ಕ್ಲಿಯರ್? ಸೊ ಗ್ಯಾಸ್ ವಿಲ್ ನಾಟ್ ಕಮ್ ಔಟ್. ಬಿ ಆಕ್ಟಿವ್ ಇನ್ ದ ಚಾಟ್ ಬಾಕ್ಸ್ ಎವ್ರಿವನ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್? ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಎವ್ರಿವನ್? Yes. So here what happens? Isolated system nalli enagutte, here no heat transfer and no mass transfer, both the things are not happening. Why? Because ಈಗ ನೋಡಿ heat apply ಮಾಡ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ outside thermos ಹೇಳ್ಬೋದು ನಾವು. okay, thermos ನಾಗ ನಾವು ಚಾ ಮಾಡ್ತೇವಪ್ಪ. okay, ಚಾ ಮಾಡಿದ ತಕ್ಷಣ when we tell, understanding? okay. ಸೊ ಯಾವಾಗ ನೀವು ಥರ್ಮಸ್ ನಲ್ಲಿ ನೀರ ಇಲ್ಲಾಂದ್ರೆ ಟೀ ಹಾಕ್ತಾರ, ಕಾಫಿ ಹಾಕ್ತಾರ, ಏನಾದ್ರು ಒಂದು ತಗೊಂಡು ಎಲ್ಲೋ ಹೋಗ್ತಿದ್ದೀರಪ್ಪ ಟ್ರಿಪ್ಗೆ. ಓಕೆ, ಸೊ ಅದ್ರ ಥರ್ಮಸ್ ನಲ್ಲಿ ಬಿಸಿ ಬಿಸಿ ಟೀ ಹಾಕಿರ್ತಾರ, ರೈಟ್? ಸೊ ಆ ಬಿಸಿ ಬಿಸಿ ಟೀಯನ್ನ ನೀವು ಅಕಸ್ಮಾತ್ ಓಕೆ ನೀವು 1-2 ತಾಸು ಆದ್ಮೇಲೆ ಕುಡಿದ್ರೂ ನಿಮಗೆ ಬಿಸಿನೇ ಇರುತ್ತದು. ಬಟ್ ನೀವು ಪೀಪಲ್ ಕ್ಯಾನ್, ಇಟ್ ವಿಲ್ ನಾಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಓನ್ಲಿ. ಈಗ ನೀವು ಬಾಟಲ್ ಅನ್ನ ಹಾಗೆ ಇಟ್ಕೋಬಹುದು, ಬಿಸಿ ಇದೆ ಅಂತ ಬಗದ್ ಬಿಡಲ್ಲ, right? So it means what? There is no transfer of the heat at the outside also, and there will be no transfer of mass also. Means what? Tea ಹೇಗಿರುತ್ತೆ ಹಾಗೆ ಇರುತ್ತೆ, ಏನು mass difference ಬರಲ್ಲ. ಯಾಕಪ್ಪ ಬರಲ್ಲ? Because it's not getting out only, no? Gas is not coming out only, right? ಉರ್ದು ಮೇ ಬೋಲ್ನಾ? ಅಯ್ಯೋ ಉರ್ದು ಬರಲ್ಲಮ್ಮ ನನಗೆ, I don't know Urdu, okay? This is the types of a system. Clear? Next comes, we are going to study these things only in detail, okay? What is the meaning of an open system, closed system and a isolated system? Clear? So first comes the open system, the type of the system where both mass and the heat transfer takes place. So what is happening there? Both mass and the heat transfer takes place with surrounding. It will takes place with the surrounding. Example, boiled water in an open vessel. Boiled water in an open vessel. That is also called as an open system. So you're boiling the water. ನೀರನ್ನ ಬೋಗಾಣಿನಲ್ಲಿ ತಗೊಂಡು ಬಿಸಿ ಮಾಡ್ತಿದ್ದೀರಾ. ಹಿಂದಿ ಮೇ ಬೋಲ, ಹಿಂದಿ ಮೇ ಕ್ಯೂ ಮಮ್ಮ? ಸೊ ಟ್ರೈ ಆಕ್ಚುಲಿ ಲೈಕ್ ಒಂದು ಬೋಗಾನಿ ತಗೊಳ್ಳಿ, ಅಲ್ಲಿ ಬೋಗಾನಿನಲ್ಲಿ ನೀರು ಹಾಕಿದ ತಕ್ಷಣ ಬಿಸಿ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ಸೊ ಬಿಸಿ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ ತಕ್ಷಣ ಬಾಯ್ಲ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಬಟ್ ಡೋಂಟ್ ಕ್ಲೋಸ್ ದ ಕಂಟೈನರ್, ಓಕೆ? ಕಂಟೈನರ್ನ ಕ್ಲೋಸ್ ಮಾಡಬೇಡಿ, ಆಯ್ತಾ? ಸೊ ದಟ್ ಟೈಮ್ ವಾಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾಪನಿಂಗ್, ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಓಪನ್ ಸಿಸ್ಟಮ್ ವೇರ್ ದ ಕಂಟೈನರ್ ವಿಲ್ ಬಿ ಓಪನ್, ದೇರ್ ವಿಲ್ ನಾಟ್ ಬಿ ಕ್ಲೋಸ್ಡ್. Clear? Next comes to the closed system. So ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ, the type of the system where only heat transfer takes place with surrounding, but there is no mass transfer. Okay, heat is getting transferred but the mass is not getting transferred. Okay, so heat ಏನಾಗುತ್ತೆ, ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿದೆ, ಹೊರಗಡೆ ನಮಗೆ ಗೊತ್ತಾಗ್ತಿದೆ heat transfer ಆಗ್ತಿದೆ ಅನ್ನೋದು, but there will not be any transfer of the water. Clear? Sorry, mass. Okay. Example, boiled water in a closed container. Boiled water in a closed container. Simple example for the closed system. Clear? Next comes isolated system. The type of a system where neither the heat transfer nor the mass transfer is happening. This is called as isolated system. Clear? Is simple idnonu image ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಟ್ರೆ open nose closed ಮತ್ತೆ isolated ಆರಾಮಾಗಿ ನೆನಪಿಟ್ಕೋಬಹುದು ಆಯ್ತಾ ಆರಾಮಾಗಿ ನೆನಪಿಟ್ಕೋಬಹುದು. Next, the universe is actually isolated because it contains everything by definition, and thus there can be a no exchange of energy with anything. So reactants undergo the reaction to decrease their energy. So to decrease their energy and will proceed until they reach the state of low energy and will remain in this state unless distributed. This state is called as an equilibrium. Means what? Whatever the universe is right now, we are not able to exchange any of the energy. It's not like I'm exchanging energy from the Mars or Jupiter and all. We are not exchanging our energy anything. It's like what? It's like an isolated system itself. We are not giving, we are not taking anything. Simple. Clear? Next, thermodynamic properties. So in thermodynamic properties, you are going to learn about the two types. First one is what? Intensive property. In intensive property, thermodynamic properties, intensive properties tells us those properties which are independent of mass. Which are independent of mass. Means what? Mass mele depend agiralla. Okay, it is not dependent on the mass. Be active in the chat box. Understanding everyone, what is the meaning of an intensive properties? Come on. Who is going to answer this? Who is going to answer this? Try this, anyone? Intensive properties andre enu? What is intensive properties? So those properties which are independent of the mass. Means what? It will not depend on the mass itself. Next comes their value remains uniform throughout the system. Okay, their value will also remain system. Means their value will remain uniform. Means same agirutte throughout the system. Clear? They are non-additive. They are actually non-additive. Clear? Understanding? So next comes the extensive property, where those properties which depend on the mass. Okay, then intensive properties will not depend on the mass, and the extensive properties will depend on the mass. Okay, and those properties which depend on the mass, the ratio of the two extensive properties become an intensive property. It will become an intensive property. Okay, and they are additive. They are additive. Clear? They are additive. Next comes intensive properties about the boiling point, temperature and the luster. Simple examples which we can give it. Okay, boiling temperature alli en tagobodu. If you people are boiling the temperature, that time what happens? The intensive properties will work. Clear? Intensive properties will work, right? So when according to the temperature also, if it is increasing, decreasing, that time also intensive property will work. Why intensive property will work? Because their properties will not depend on the mass. See now, here we are increasing the temperature, the water quantity, the mass will actually decrease. When you apply a temperature, ನೀವು ಯಾವಾಗ apply ಮಾಡ್ತಿರ್ತಾರಲ್ಲ temperature ನ, ನೀರು ಕಡಿಮೆ ಆಕ್ಕೊಂತ ಹೋಗುತ್ತೆ. It will reduce, it will decrease, right? So but if the temperature also same thing. ಈಗ ಅಕಸ್ಮಾತ್ ನನ್ನ ಈಗ temperature ಬೇರೆ ಇದೆಯಪ್ಪ, ಇನ್ನೊಂದು ಅರ್ಧ ತಾಸು ಆದ್ಮೇಲೆ ಬೇರೆ temperature ಆಗುತ್ತೆ. So depends on that also, right? So next comes the luster. Okay, luster means what? Luster also is like shiny substances where it will not depend. Sometimes it will go, sometimes it will not, right? Sometimes it will come shine, sometimes it will not come to shine. Now intensive properties again ಕೊಡ್ಬೋದು. So it will depend on the mass. They have told there how much volume you have taken depends. ಈಗ ಅಕಸ್ಮಾತ್ 10 ml ತಗೊಂಡಿದ್ರಂದ್ರೆ 10 ml ಇರ್ಬೇಕಪ್ಪ ಅದು, right? So next comes the mass. So how much mass you have taken, that is also important while preparing any chemical reaction. Weight also is dependent here, right? Weight is also dependent, like how much weight you have taken it, right? So that is how the intensive properties and extensive properties are going to work. Clear? Are going to work. Next, extensive properties and intensive properties. There are two forms. So how you can easily remember? Like volume means what? Molar volume will come. Clear? Volume andre molar volume bartate. Number of moles andre density barbohudu. Clear? Mass andre refractive index, intensive property. So it is a free energy, then it is a surface tension, entropy, viscosity, enthalpy, free energy per mole, per mole, internal energy, here specific heat capacity, here pressure, temperature, boiling point, freezing point will be there. Clear? Extensive properties and intensive properties are clear. So extensive properties, intensive properties are the properties where they will not depend on the mass. Clear? So they will not depend on the mass. However they can do it. But in the extensive property, it will depend on the mass. Okay? It will depend on the mass. Next comes the state function. State function alli enaಗ್ತಿದೆ, those thermodynamics properties which depend on initial and final state, which will depend on what? Initial and the final state. Clear? So examples ಏನು ತಗೋಬಹುದು? Pressure, volume, temperature, Gibbs free energy, internal energy, entropy. So these are the simple examples which you can take it for the state function. Clear? So those thermodynamic properties which will depend on initial and the final state. Initial and the final state andre ಏನು? Initial ಆಗಿ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇದೆ, but final ಆಗಿ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇದೆ. ಕ್ಲಿಯರಾ? ಸೊ ಇನಿಷಿಯಲಿ ನಾನು ಲಿಕ್ವಿಡ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇದ್ದೆ, ಮತ್ತೆ ಆಮೇಲೆ ಅಟ್ ದ ಎಂಡ್ ಮೀನ್ಸ್ ಫೈನಲ್ ನಲ್ಲಿ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆದ್ರೆ ಅದು ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಕ್ಲಿಯರಾ? ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಎಕ್ಸಾಂಪಲ್ಸ್ ತಗೋಬಹುದು, ಪ್ರೆಷರ್, ವಾಲ್ಯೂಮ್ ಅಂಡ್ ಟೆಂಪರೇಚರ್ ಅಂಡ್ ಆಲ್. Next comes the path function. Okay, next comes the path function. Those properties which depend on the path, which will depend on the path. Means what? Like example, heat, work, loss of energy due to the friction. Like what? Depending on the path means what? Whether it has been heated up. Okay, in heated up agide, no? Whether it is going to be like in the form of losing the energy, whether it is getting the work done or no, depends on that also. Clear? Next, see, this is path A and path B. Okay, how it's going to work? So you think like example, this person will get into the lift. Okay, this person will get into the lift. Iga aa mansha state 2 hogtane. Means what? Before that he was actually pressing the lift. Okay, before that he was trying to press the lift. Next, in path B, what happens actually? In path B, what happens? State 1 is he is actually moving till the first floor. He is taking the steps and he is going to the first floor. So elevation gain is what? He is actually going to the state 2 by taking the more time. Okay, by taking it a more time. Pathway and AB are same. They both are going to the home. Ibru manegane ಹೋಗಿ ಮುಟ್ತಿದ್ದಾರೆ, ಬಟ್ ಒಬ್ಬ ಮನುಷ್ಯ ಏನ್ ಮಾಡ್ತಾನೆ? ಲಿಫ್ಟ್ ಇಂದ ಹೋಗ್ತಾನೆ. ಇನ್ನೊಬ್ಬ ಮನುಷ್ಯ ಏನ್ ಮಾಡ್ತಾನೆ? He will go by the ಸ್ಟೆಪ್ಸ್ ಎಲ್ಲ ಹೋಗ್ತಿದ್ದಾನೆ. ಆಯ್ತಾ? ಸೊ ಇಲ್ಲಿ ಸ್ಟೆಪ್ಸ್ ಇಂದ ಹೋಗ್ತಿದ್ದಾನೆ ಮತ್ತೆ ಇಲ್ಲಿಂದ ಲಿಫ್ಟ್ ಇಂದ ಹೋಗ್ತಿದ್ದಾನೆ. ಕ್ಲಿಯರಾ? ಸೊ ಈಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲಿ ಪಾತ್ ಎ ಪಾತ್ ಬಿ ನಲ್ಲಿ, ಪಾತ್ ಎ ನಲ್ಲಿ ಟೈಮ್ ಕನ್ಸಂಪ್ಷನ್ ಇಸ್ ಲೆಸ್. ಓಕೆ, ಪಾತ್ ಬಿ ನಲ್ಲಿ ಟೈಮ್ ಕನ್ಸಂಪ್ಷನ್ ಇಸ್ ಮೋರ್ ಆಕ್ಚುಲಿ. Right? So this is how the path A and path B will work. That is what they are trying to tell. Those properties which depend on the path. Now, if you are heating it, okay, nee heat martida enadru. So if you give more temperature, the work will be done faster. If you give less temperature, the work will be done less. Simple, right? Easy to understand, right? So this is a path A and path B simple example to make you understand it. Okay. Next comes the thermodynamic process. So how the thermodynamic process is actually been working. Okay, be active in the chat box everyone. Be active. ತಿಳಿತಿದೆನಾ? Understanding? Understanding? Now what happens here? The change of the thermodynamic state from one condition to the another condition is called as thermodynamic process. So it means what? One condition is present to it. Okay, one ಯಾವುದೋ condition ನಲ್ಲಿ ನಾವು ಇದ್ದೇವೆ already. Okay, ಆ condition ಇಂದ ಇನ್ನೊಂದು condition change ಆಗ್ಲಿಕ್ಕೆ, right now I am having a fever. Okay, ಆ fever ಅನ್ನು convert ಮಾಡ್ಲಿಕ್ಕೆ ಬೇರೆ, I am very well right now. Okay, so ಆ convert ಮಾಡ್ಲಿಕ್ಕೆ ಏನಾಗುತ್ತಲ್ಲ, that condition which is changing, that is called as thermodynamic process. That is called as thermodynamic process. So this is the graph, simple graph which is present. Clear? So this is log V versus log K, where log P is present here, how it's been decreasing. When you're increasing the log K ಯಾವಾಗ increase ಆಕೊಂತ ಹೋಗ್ತಿದೆಯಲ್ಲ, according to that it's decreasing also to the log V. Okay, it's decreasing to the log V. So for that purpose, slope will be what? -1. Slope will be what? -1. Next comes the reversible process and irreversible process. So what is the meaning of a reversible and a irreversible process? Idan you already kaltirtera, but let us repeat it once again. What is the meaning of that? Okay. Now driving force in the infinitesimally small. Here what happens? Irreversible mein driving force in a large and finite way. Okay. Large and finite way ಏನಂತ ಕರೀತಾರೆ? Irreversible process. Okay. Now what happens in the reversible process again? PV, that is work is done across pressure difference and dP. Clear? Here PV work is actually done across the pressure difference of delta P. It's actually across the delta P. Okay. Next comes what? A reversible heat transfer takes place across temperature, differs in dt. It will differ in what? dt. But what happens in the irreversible? Heat transfer take place across the difference in delta t. ಇಲ್ಲಿ delta p in the difference ಆಗುತ್ತೆ, ಇಲ್ಲಿ delta t in the difference ಆಗುತ್ತೆ. Clear? Clear? Hi. Good morning, appa. It's good evening. Why good morning? It is an ideal process. It's an ideal process. Here it is a real process. It's an ideal process, and there it is a real process. Now it takes place, it takes infinite time for the completion of the process. It takes finite time for the completion of a process. So it is an imaginary process and cannot be realized in actual practice, but it is a natural process. Irreversible process is a natural process. It's a natural process, and it occurs in a particular direction under given set of a condition. Under given set of a direction means what? It's just like a robot. Okay, it's just like a robot. ನಾನು ಇದನ್ನ ಮಾಡಂತಿದ್ದೆ, ನಿಂಗೆ ರಿಯಾಕ್ಷನ್ ಅದನ್ನ ನೀವು ಮಾಡಬೇಕು, ಆ ಥರ ಅದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು. Okay, like that you can consider it. Next, this is the reversible process, how it's working. Initial process, how it's there. So now when you start restoring them, how it's going to work. Clear? Once you start restoring them, this is how it's going to work. Now, if this is an irreversible process, see, I have added a stone here. So the air is present here, the ice cubes are present. So once the air means the temperature will increase, the air is there, then obviously temperature will be there. Then the water, it will get converted, stone will be there itself, nothing will change. Air also will be there, but ice cubes will be converted into the water. Means what? We are making the ice cubes to melt. Okay, we are making the ice cubes to melt. That's what I told you. It's just like a robot. Na in ಹೇಳ್ತಾನೆ ಅದನ್ನ ಮಾಡುತ್ತೆ. ಆಯ್ತಾ? Next, state function. Now, those thermodynamic properties which depend on the initial and the final state, example delta E or delta U, where delta H and delta S, delta G, etc. So, path function is, you know, those properties which depend on the path, example work and the heat. Now next comes the general terms. So general terms are also important, like what is the meaning of an water, what is a work, how the work is being done, how the sign conventions are done, and how the units of that work is being going on, that we are going to see. Okay, first is about the work, that is those properties which depends on the path, that is work and heat. So work means what? Thermodynamic work is going to be what? W is equal to P delta V. Okay, W is equal to P delta V. Now sign convention ಏನಾಗುತ್ತೆ ಹಂಗೆ? Comparison, that is positive is going to be what? Work done on the system. If it's going to be positive, then work is done. Work is done on a system. On a system. Okay, this is important. On is important. On system. Okay, on the system. So how the sign convention is going to happen? When it's going to be positive, it will be on the system, work is happening on the system. If it is expansion, it is going to be expansion, then that time it will be negative. Work done by the system means expansion. Clear? So work done by the system is going to be negative. Negative means what? Negative means work done by the system. Work done by the system. Clear? Yes. Now how it comes? The unit of the work, that is ATM into liter. Okay. 1 ATM is into 1 liter, that is going to be 24.23 calories. So it will be how much? 24.23 calories. Clear? So 1 ATM is equal to what? Lit, that is going to be 101.3 joules. Then 1 calories is equal to how much here? 4.18 joules. 1 joules is going to 107 irg, and 1 joule is equal to 0.24 calorie. Okay, 0.24 calorie. Now 1 ATM is into liter, that is greater than 1 calorie, that is greater than 1 joule, that is greater than 1 erg. That is going to be greater than 1 erg. So these units are also very important. You need to study these units also very nicely. Okay, you need to learn these units also properly. Done? Understood? Next comes, for small displacement dx due to the force F, work done on the system, that is dw is equal to F dx. dw is equal to F dx. What happens here? Also F is equal to, F value in Baratilli, F is also going to be PA. F is also going to be PA. Means what? dw which is present, dw is actually equal to F dx. Okay. Andre IF is actually equal to PA. Now what happens? dw is equal to PA dx. Means what? In this F they have added the value of the this. On this F they have added the value of PA. Clear? Next going to be here, P is going to be the pressure, A is going to be the area, and V is going to be the volume. Now V is equal to L minus X of A, where dV is equal to minus A into dx, minus A into dx, and dW is going to be minus P extent into dV. So there the WPV is actually equal to integration of V1 to V2 of P extent to dV. Means what? They are differentiating it. Okay, they are differentiating the pressure with the volume. They are differentiating the pressure with the volume. Clear? So the normal derivation maths nalli, so adhe tara they have just converted that. Clear? Understood? Understood? Say yes if you have understood it. Come on. Hello, hello. Say yes if you have understood it. Yes. Let's move to the next part. Heat. Now, by differences in the temperature, the total amount of the energy transferred from one body to the another. Means what? From one body to the another body, if you are changing, means you are changing the energy, if you are transferring the energy, then that is going to be known as what? Heat. Okay, that is going to be known as heat. Now, sign convention hengagatte? If in case heat is observed by the system, then it will be positive. Okay, if it has been observed by the system, then it will be positive. Now, if in case heat has been evolved, means only ಹೊರಗಡೆ ಹೋಗ್ತಿದೆ. Hello, ಹೊರಗಡೆ ಹೋಗ್ತಿದೆ, ಅವಾಗ ಏನಾಗುತ್ತೆ? System negative ಆಗುತ್ತೆ. Means what? You should remember that heat is getting observed by, or heat is getting observed by the system. Okay, evolve ಆಗ್ತಿದೆನೋ observe ಆಗ್ತಿದೆನೋ ಅನ್ನೋದು important. Okay, in case observe ಆಗ್ತಿದ್ರೆ positive, evolve ಆಗ್ತಿದ್ರೆ negative. This is very important to solve the problems. Okay, ಇದು ಬಹಳ important. Sign convention is very important to solve the problems. Clear? Next comes internal energy, that is E or U, or hidden energy. Okay, internal energy, that is E or U, or it is also called as hidden energy. Okay, can you show me? Next comes what here? Sum of the various type of energy related with a system is known as internal energy. Sum of various type, say sum of various type of energy which is related with the system is known as the internal energy. Now if E or U, okay, E or U is there, potential energy is actually plus the kinetic energy, then it is going to be what? Potential energy, that is going to be the once again, potential energy, kinetic energy, one second guys. Okay, now next comes what? Energy due to the gravitational pull is, energy due to the gravitational pull is not considered in internal energy. It's not going to be considered in the internal energy. Means what? In internal energy, that is not going to be participating. Clear? So now, it is impossible to calculate the absolute value of the internal energy. So, internal energy andre yavadadru one system internally aagtide. Okay, in the internal it is happening by closing the all system. That time what is going to happen? That time the calculation means what? The calculation of the absolute value will be very difficult, because what is happening at the inside, that is very difficult to calculate also. Okay, now calculate the exact value of all the type of the energy at a time. So, the internal energy is an extensive property and it is a state function. It is going to be the extensive property and it's going to be the state function. Clear? Now, what is the relationship between the internal energy and the pressure for 1 mole of ideal gas and a per unit volume? Okay, 1 mole of an ideal gas and per unit volume. So, in ideal gas, internal energy, that is kinetic energy, is equal to 3 by 2 divided by RT. That you should remember. Okay, so kinetic energy here is going to be what? Three by 2 divided by RT for 1 mole. For 1 mole, it's going to be how much? Kinetic energy is going to be 3 by 2 divided by RT. Now there, PV is going to act like an nRT. Okay, chemical equilibrium kaltartarala. PV is equal to nRT. And here P into 1 is equal to 1 into R. P into 1 is equal to N into R. Clear? Understanding? Understanding? Then say yes in the chat box fast. Let's see how many people are understanding it. Come on. Hello Chini. So many days you have not come to the class only. You came just now from the college. Oh, okay. PV is equal to nRT and P into 1 is equal to 1 into RT. Okay, it's okay, no problem. So next comes what? P is equal to RT, we know it already, right? Now U is going to be 3 by 2 into pressure, 3 by 2 into pressure. So where the ionic energy is going to be what? Kinetic energy is equal to 3 by 2 P. So it is going to be how much? 3 by 2 P. Clear? So the properties which arise out of collective behavior. Collective behavior in the outside is the raise ಆಗ್ತಿದೆ the temperature. Okay. ಅವಾಗೇನಾಗುತ್ತೆ? Large number of chemical entities will be present. Example, pressure, volume, temperature, composition, color refractive index, etc. So this all are the simple examples for those things. Okay. Next comes the zeroth law of thermodynamics, which is also important. Means first zeroth law irutte, ಆಮೇಲೆ we are going to learn about the first thermodynamics, first law of thermodynamics, ಆಮೇಲೆ third law of the thermodynamics we are going to learn. Clear? So zeroth law of thermodynamics means what? Whenever two different systems are in thermal equilibrium. Okay, ಎರಡು equal. Okay, concentrate properly. Understanding everyone? Yes. So when two different systems are in the thermal equilibrium, okay, two different systems will be actually included in the equilibrium with third system separately, then it will be always be in a thermal equilibrium with each other. Means what? Yeah, they have two different okay, two different system iruttalla, alli yav thermal equilibrium naditide alla with the third system, third system today in equilibrium naditide alla. So avella separately they will also form a thermal equilibrium. They will also form a thermal equilibrium with each other. Clear? Next, how it's working here? TA and TB is always equal. Okay, here TB is also equal to TC. So concentrate now. If in case TA and TB is equal, here TB and TC is equal, then obviously TA and TC is equal. Right? TC and TC is also equal. TA and TC is also equal. That is what they have told. If in case TA is equal to TB and TB is equal to TC, then TA is also equal to TC. Clear? TC is also equal to TC. Clear? Okay, no problem, Mama, no problem. So clear? Understood this? Next comes types of a thermodynamical process. So what is the types of thermodynamical process? First comes the isobaric process. So what is the meaning of an isobaric process? Where the pressure is actually converting the constant, that is going to be delta P is going to be the 0. Delta P ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. Clear? So next ಏನು thermodynamic work W is equal to plus or minus P delta V. So W is equal to what? P plus or minus P delta V. Here what happens? W is going to act like a F into DL. F into DL, because we know already what is P. P is F. Right? ಇಲ್ಲಿ ನೋಡಿದ್ವಲ್ಲ? P dx. Right? Here only F is equal to PA. That's what we have taken it here. Right? So P into A. Sorry, A barod maratna. Okay. 1 second. Okay. Now W is equal to F into DL, where P into A into DL is present, where the pressure is actually present with the area into the change in the length. So for that purpose, P into V is going to be the delta PV. For that purpose, P into V is going to be what? Delta PV. Clear? Understanding? Yes. Now W is equal to what is going to happen? P into delta V, where because P is going to be the constant. Okay. Avaga P constant agi act madutte. P will act like a constant. Now next point comes what? If in question, in case they are asking you people, if in case they are asking you people, okay, if in case they are asking you people like question process is not given, then we will consider isobaric, because maximum process are carried out in open vessel, okay, where pressure is being constant, where the pressure is going to be constant, and most of the things are going to act in the open vessel itself. So yella jasti open vessel nallene cook agodu. So you also might have seen. So experiments also yavag ಮಾಡ್ತೇವಲ್ಲ, reactions yavag ಆಗ್ತಿರತ್ತಲ್ಲ, almost most of the things will be open itself. Vessels will be open itself. Very less things are there which are actually are closed containers. Okay. So that's what we need to learn more about, how the reactions are happening in the open vessel. Clear? Yes. Now comes the isochoric process. So now first one is done. Everyone clear with this? Isobaric process is clear? Isobaric process is clear, everyone? Come on. Tell yes if you have understood the isobaric process. Isobaric process clear, huh? So next comes the isochoric process. Here what happens, the volume which is going to be the constant, delta V is equal to 0, and here thermodynamic work, that is W, is going to be the 0. So this is how the isochoric process is going to happen. See, constant volume container ಇದೆ. Okay, ಇದ್ರಲ್ಲಿನೂ ಅಷ್ಟೇ ml water ಇದೆ, ಇಲ್ಲಿ ಅಷ್ಟೇ ml water ಇದೆ. So ಎರಡಕ್ಕೂ temperature ಹಾಕ್ತಿದ್ದಾರೆ. They are applying the pressure also, they are applying the temperature also. Clear? So they will be having a constant volume container. They have a constant volume container. Clear? Understood that isochoric? Isochoric andre volume constant irutte, and isobaric nalli pressure constant irutte. Isobaric means pressure will be constant. Isochoric means the volume will be constant. Clear? Let's move to the next part, that is isothermal process. Third one comes what? Isothermal. Iga isothermal nalli enagtide, see, if in case temperature is going to be constant in the isothermal process, how it's going to act with the ideal reaction. Okay, how it's going to act with the ideal reaction now. So ideal gas equation is going to be what? PV is equal to nRT. It will be how much? PV is equal to nRT. Now here, so PV is going to be the constant, where P1 V1 is going to act like an P2 V2. It will act like an how? P1 V1 is equal to P2 V2. Now for ideal gas and the isothermal processes, then change in internal energy, that is delta U is equal to 0. Delta U is equal to 0. Clear? Delta U is equal to 0. When internal energy ಯಾವಾಗ 0 ಇರುತ್ತೆ? So internal energy ಯಾವಾಗ 0 ಇರುತ್ತೆ? For an ideal solution and ideal gas and the isothermal process, the change in the internal energy delta U is going to change. Okay, delta U is going to change. So internal energy is actually equal to what? Kinetic energy. You know already kinetic energy, that is minus 3 by 2 RT. Right? Minus 3 by 2 RT. So ಅದರ ಸಲುವಾಗಿ ಯಾವಾಗಲೂ delta U, that is internal energy, is always equal to the kinetic energy, and that kinetic energy is going to be what? Minus 3 by 2 RT. We know already R. Right? Constant is the gas constant. What is the T? Temperature. How much temperature they give, we will apply. If they have not given the temperature, let us consider as a constant. Constant andre yavadu? 298 Kelvin illada 25 degrees Celsius. Okay? Depends on that. If you have given, better and well. If they have not given, we should consider it. Okay? Now internal energy is directly proportional to the temperature. Okay? Internal energy is directly proportional to the temperature, where delta ionization energy is directly proportional to the delta T. Delta T. So change in the internal energy is actually directly proportional to the change in the temperature. For that purpose, change in internal energy is going to be the 0 or else constant. Clear? How it's going to be the constant? Understanding? Be active in the chat box. Understanding, everyone? Yes? Yes. Next comes the ideal gas, that is isothermal, and moles are constant. The ideal gas, isothermal, and moles are going to be the constant. So here what happens? Change in the enthalpy, that is delta H, is going to be 0. Change in the enthalpy, that is delta H, is going to be 0. Clear? So here delta H is equal to delta U plus delta NGRT. So delta U plus delta NGRT. So delta H is going to be 0. So the rough log of P versus log V for the isothermal process is going to be what? PV is equal to K, and where log P is actually plus log V is going to act with the log K. Clear? So log P plus log V is going to act with the log K. It's going to act with the log K. So Y is equal to mx plus C. Clear? So this is how the isothermal process is going to happen. Okay? Isothermal process, how the volume. Whenever you are applying a temperature, means what? Temperature is increasing. The volume also will decrease. No guys? Right? So ಈಗ ನೀವು temperature apply ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಿದ್ದೀರಾ, heat apply ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಿದ್ದೀರಾ. So one of the other day the volume, ಎಷ್ಟು volume ತಗೊಂಡಿರ್ತೀರಾ, ಅದು decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ. Right? It will start decreasing. Right? Am I right? Next comes what? This is how the structure is going to look. So this is how the decrease it is happening. So in here just now the decrease is happening there. Decrease of log V, that is volume. volume is getting decreased. How the volume is getting decreased? When you are increasing the temperature. So you are increasing the temperature, for that purpose decrease of the volume is happening. Clear? Understood? Yes. Fourth one is what? Adiabatic process. So now we studied three types: isobaric, isochoric, isothermal. Next comes the adiabatic process. So what is actually happening in the adiabatic process? So no transformation of heat with the surrounding. It means what? Q is equal to 0. Q is actually equal to what? 0. Clear? So where PV is equal to constant, where TV lambda minus 1 is equal to constant. So TP is also equal to the constant itself. So the lambda is going to be the Poisson rate. So this is going to be Cp divided by Cv, where PV is equal to going to act like an K. This is very important. Learn it properly, okay? Practice maadi idanna derivation. Simple derivation it is, okay? This is how the reaction is going to happen. Adiabatic process here, isothermal versus adiabatic, how it acts. Now, let's come to the next part, that is first law of thermodynamics. Okay, first law of thermodynamics. So, in first law of thermodynamics, have you studied in the zeroth law? No, like that latest, but there will be a changes in according to the laws. Okay, hey, laws increase other changes to So, first law now Robert Meyer and Helmholtz, who was the scientist who told us about the first law of thermodynamics, what did he say is, whatever the total energy of the universe is present always remains constant. Okay, whatever the total universe is present, okay, it will remain constant. Yella universe enidella ella constant agulite, therefore energy can neither be created nor be destroyed. Clear? So it's a constant, universe is a constant. So adra salvagi energy in creative madlikagalla, energy anna transfer means it can't be destroyed. Okay, transfer madlik barutte, but destroy madlikunu baralla. ಈಗ ನಾನು ಏನಾದರೂ ತಿಂದೆಪ್ಪ ನನಗೆ energy ಬಂದ್ಬಿಡ್ತು. Okay, now once I get the energy, I will not be able to destroy it. So I need to use it. By doing something only, my energy is going to get destroyed. Means energy will become less if I do more work. That's what I can do it. But I can't do it immediately, like I have got energy right now, then I can't go and throw my energy somewhere. Okay, Cheta. Next, first, total energy of the universe always remains constant. That is, energy can neither be created nor be destroyed. Next, according to the plot, that is the first law of thermodynamics, one form of energy can be completely converted into the another form of energy. It means what? It can be transferred. It can be transferred. Means what? One energy in the means it can be transferred from one form to the another form, but it can't be destroyed. It can't be created. Okay. Mathematically, let work done of the system be W. Okay, and heat observed by the system be Q. So then what is going to be the answer? Then delta E is actually going to act like Q plus W. Delta E is going to act like Q plus W. Clear? Q plus W. So what will be the application of first law of thermodynamics? What will be the application of first law of thermodynamics? Here what happens? His law, it is his law, okay? His law of a constant heat summarization, where according to this law, the net amount of heat change, whatever the net amount of the heat change is happening in the complete process is the same regardless of the method employed. So when the chemical change can be made to take place in, when the chemical change is going to be made, it is going to made to take place in two or more ways. It's going to take place in two or more ways, which involves one of the more steps. It is going to involve one of the more steps. Clear? Understood? So how it's going to happen? Just observe here properly, everyone. So in A, one system is getting converted to B. Okay? Directly convert into C. C to D. It means what? Whatever, according to this, what it tells you, whatever the net amount of heat change, I'll mark it here, wait. Net amount of heat change, whatever it is happening in the complete process is the same, is going to be the same regardless of the method employed when chemical change can be made to take place in 2 or more ways which involves 1 or more steps. Means what? We need to apply chemically. ಯಾವಾಗ ನಾವು chemically apply ಮಾಡ್ತೇವಲ್ಲ ಅವಾಗನೇ reaction ಸರಿಯಾಗಿ ಆಗೋದು. Clear? That is what they are trying to tell us. His law is actually telling us about the constant heat summarization. Okay. For that purpose, whatever the heat is taken, how much the heat to transfer to chemical reaction to happen, how much necessary of the heat is there, that Q is actually equal to Q1 plus Q2 plus Q3. Clear? Q1 plus Q2 plus Q3. Clear everyone? ತಿಳಿತಿದೆನಾ ಎಲ್ಲರಿಗೂ? Yes. Next comes the molar heat capacity and GM specific heat. So what happens with the molar heat capacity? Iga molar heat capacity andre we know how the heat is been working out now. Okay. Now thermodynamics kaliyodane it's because of the temperature, pressure, heat ಏನು ಕಲಿತಿದೇವಲ್ಲ it's all about the temperature ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡೋದು, heat ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡೋದು, pressure ಹೇಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ನಮಗೆ ಅವನ್ ಕಲಿತಿದ್ದೇವೆ. ಈಗ molar heat ಅಂದ್ರೆ ಏನು? ಈಗ you people tell me the answer like, so ಈಗ ನಾನು ಏನೋ ಒಂದು weight ತಗೊಂಡಿದ್ದೇನೆ, if it in case okay weight is been increasing, if in case weight is been increasing, then whether that how much temperature you are actually applying to that weight is applicable. You tell me whether it is applicable. You tell, come on, answer it, let's see. So ಈಗ ಎಷ್ಟು weight ತಗೊಂಡಿದ್ದೇನಪ್ಪ, 1 kg weight ತಗೊಂಡಿದ್ದೇನೆ, 1 kg weight of jaggery I have taken it. Okay, ನಾನು heat apply actually 1/2 kg of jaggery ತಗೊಂಡಾಗ 100 degree Celsius apply ಮಾಡ್ತಿದ್ದೆ heat. Okay, ನಾನೀಗ 1 kg heat jaggery ತಗೊಂಡಾಗನು 100 degree Celsius heat apply ಮಾಡ್ತಿದ್ದೇನೆ. ಈಗ ಏನ್ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ ಇದು? How it will be affect? It affects on the mass also. ಓಕೆ, ನಾವು ಯಾವ ಥರ ಟೆಂಪ್ರೇಚರ್ ಹಾಕ್ತಿದ್ದೇವೆ, ಯಾವ ಥರ ಪ್ರೆಷರ್ ಹಾಕ್ತಿದ್ದೇವೆ, ಅದೆಲ್ಲ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಹೌ ಮಚ್ ದ molar heat capacity, how much is there, how much we have taken the weight, it depends on that also. That is what we are going to learn. Okay, now C is equal to Q divided by delta T for 1 mole. Okay, ಏನಾಗುತ್ತಪ್ಪ, for 1 mole C is going to act like what? Q divided by delta T. It is going to act like what? Q divided by delta T. Now here the molar heat capacity at constant pressure, here the molar heat capacity of a constant pressure is going to be the Cp. It's going to be how much? Cp. Clear? Now Cp is equal to Qp divided by delta T. Cp is equal to Qp divided by delta T. That is going to be what? Change in a heat, change in heat, whatever the change is happening, that divided by delta T, change in the temperature, change in the temperature for 1 mole. We are discussing only about the 1 mole right now. Okay, Cp is equal to what? Qp divided by delta T, where delta H is actually divided by delta T. Clear? Yes, so delta H is going to be what? Cp delta T. So delta H is going to act like what? Cp delta T, means whatever the concentration of that pressure, we are going to take it according to that. Okay, according to that. Next, for n mole is equal to what? Delta T is going to be delta F minus Tf, Tf minus Ti. Means what? I told you temperature is going to depend on the initial position and the final position. So you should be very careful with those things. Okay. So next comes unit of the Cp. That will be what? J divided by, means you got to know this formula first. This is very important. Okay, final position ಎಷ್ಟಾಗಿದೆ and initial position. Initial ಎಷ್ಟಾಗಿದೆ ಮತ್ತೆ final ಎಷ್ಟಾಗಿದೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಇರೋದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಯೂನಿಟ್ ಆಫ್ Cp is equal to joules ಇದೆ. joules ಯಾವಾಗ temperature divided by K minus moles. That will be joules will be calculated on the basis of calories also. So calories divided by K in minus mole. Clear? So that if you K minus mole ಅನ್ನ ಮೇಲ್ಗಡೆ ತಗೊಂಡ್ಬಂದ್ರೆ calories per Kelvin per mole ಅಂತ ಬರ್ಕೋಬಹುದು. ಆಯ್ತಾ? So this is how the molar heat capacity is going to work, where delta T is going to be what? Tf minus Ti. Tf minus Ti. Next comes molar heat capacity at constant volume. So molar heat capacity at constant volume. So Cv is equal to Qv divided by RT. Qv divided by RT. So how it's going to act? Delta U is equal to delta T. Delta U is actually equal to the delta T. Here ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ for 1 mole this is how it's working. Okay, 1 mole ಆಗ್ತಿದೆ ಇದು. ಸೊ 1 ಮೋಲ್ಗೆ ಏನು ಹೀಟ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಆ ವಾಲ್ಯೂಮ್ಗೆ, ಸೊ ನಾವು ಯಾವ್ದು ವಾಲ್ಯೂಮ್ ತಗೊಂಡಿದ್ದೇವಲ್ಲ, ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ಆರ್ ವಾಟ್ ಹೌ ಮಚ್ ಎವರ್ ಅಮೌಂಟ್ ಆಫ್ ಅ ಕೆಮಿಕಲ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ಇಟ್ ಇನ್ ಅ ಲಿಕ್ವಿಡ್ ಫಾರ್ಮ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅ ಲೀಟರ್, ಸೊ ಅಲ್ಲಿ ಎಷ್ಟು ಹೀಟ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೇವೆ ಮೀನ್ಸ್ ಹೌ ಮಚ್ ಟೆಂಪರೇಚರ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ಇಟ್, ದಟ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ ಸೇಮ್ ಅದೇ ತರ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಡಿವೈಡೆಡ್ ಬೈ ಡೆಲ್ಟಾ ಟಿ. ಕ್ಲಿಯರ್? ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಯು. ಕ್ಲಿಯರ್? So QV is equal to QV is equal to delta U is equal to CV delta T for 1 mole. Then for n mole of delta E is equal to n CVD delta T. So delta E is equal to what? N CV delta T. Done. Next comes unit of CV, that is joules, that is divided by K minus mole or cal, that is what repeated again. So next comes the gram specific heat. Gram specific heat. Clear with the molar heat everyone? Molar heat is done. Next comes the gram specific heat. Okay, gram specific heat nalli enagutte, amount of a heat required to raise the temperature of, it is getting raised the temperature means what, we are getting raised means what, 1 gram of a thing means ಅದೇ ತರ ಒಂದು ಸ್ವಲ್ಪ ಏನೋ ಒಂದು ಕಂಟೈನರ್ ತಗೊಂಡಿದ್ದೇವೆ, we have taken one substances in that. Okay, we have taken a substances in that, we are applying the temperature to that. Okay, ಆ substances ಗೆ ನಾವು ಟೆಂಪರೇಚರ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೇವೆ. ಸೊ ಅಕಸ್ಮಾತ್ ಆಗಿ ನಾವು 1 kg ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಬಿಟ್ಟು ನಾ 2 kg ಸಬ್ಸ್ಟೆನ್ಸಸ್ ತಗೊಂಡೆ, ಹೀಟ್ ಅಪ್ಲೈ ಅಷ್ಟೇ ಮಾಡ್ತಿದ್ದೇನೆ, ಎಷ್ಟು ಅಪ್ಲೈ ನಾವು ಫಸ್ಟ್ ಮಾಡ್ತಿದ್ದೆ ಅಲ್ಲ, ಸೇಮ್ ಅಪ್ಲಿಕೇಶನ್ ವಿ ವಾಸ್ ಡೂಯಿಂಗ್ ಫಾರ್ ದ ಸೆಕೆಂಡ್ ಆಲ್ಸೋ. Okay, so what is happening that time, adna now understand ಮಾಡ್ಕೊಳ್ಳೋದು ಇಲ್ಲಿ. Okay, ಗ್ರಾಮ್ ನಲ್ಲಿ. So what is happening, the amount of the heat required to raise the temperature of 1 gram of substances by 1 degree Celsius or 1 Kelvin is known as gram specific heat. Okay, is known as gram specific heat. Hi Sunita. So C is equal to Q divided by delta T. C is equal to what? Q divided by delta T for 1 gram. Okay, for 1 gram. Next now gram specific heat at constant pressure. Clear understanding in a gram andre? Gram andre ತಿಳಿತಾ ಎಲ್ಲರಿಗೂ? ತಿಳಿತಾ? ನೀನು ಬಾಯ್ ಅಮ್ಮ, ನಾವು ವಿಚ್ ಕಾನ್ಸೆಪ್ಟ್ ಮ್ಯಾಮ್? ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಕಲಿತು ಸುನೀತ್. So, oh, you are okay. This account is different, ah? Okay, done. Hi, boy. What's your name then? So, gram specific heat nalli ಏನಾಗ್ತಿದೆ, the amount of the heat required to raise the temperature of 1 gram. Okay, what 1 gram of 1 degree Celsius. ಏನ್ raise ಮಾಡ್ತಿದ್ದೇವೆ, 1 gram ಅನ್ನ raise ಮಾಡ್ತಿದ್ದೇವೆ. How much temperature we are applying? 1 degree Celsius we are applying. Clear? So, gram specific heat is going to at constant pressure ನಲ್ಲಿ ಏನಾಗುತ್ತೆ, Cp is going to be what? Qp divided by delta T. Qp divided by delta T. For same for 1 gram itself, ಅಲ್ಲಿ 1 mole ಮಾಡ್ತಿದ್ವಿ because we were studying about the molar heat capacity. ಇಲ್ಲಿ ಹೇಗೆ ಮಾಡ್ತಿದ್ದೇವೆ? Myself Anish. Hi Anish. Okay, here what is happening? Here we are learning about the gram. Okay, ಅದರ ಸಲುವಾಗಿ we are learning only for the mole different. For the gram it is going to be different. So Cp is equal to delta H divided by delta V. So delta H divided by delta T. So for 1 gram same itself. So for m gram, that is delta H is equal to mCp delta T. mCp delta T. Clear? So unit of Cp is equal to joules divided by kilogram. That is going to be calorie divided by kilogram. Clear? Understood? Same ಅದೇ ತರ ಮೋಲ್ಗೆ ಏನಾಗಿದೆ ಅಲ್ಲ, ಸೇಮ್ ಅದೇ ತರ ಇದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಗ್ರಾಮ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಟ್ ಕಾನ್ಸ್ಟಂಟ್ ವಾಲ್ಯೂಮ್. ಸೊ ಈಗ ಇಲ್ಲಿ ಕಲ್ತ್ವಿ ಗ್ರಾಮ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಟ್ ಕಾನ್ಸ್ಟಂಟ್ ಪ್ರೆಷರ್ಗೆ. ಓಕೆ, ವಿ ಲರ್ನ್ ಅಬೌಟ್ ದ ಕಾನ್ಸ್ಟಂಟ್ ಪ್ರೆಷರ್. ನಾವ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಅಬೌಟ್ ದ ಕಾನ್ಸ್ಟಂಟ್ ವಾಲ್ಯೂಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಗ್ರಾಮ್ specific unit. Okay, how the gram specific heat is going to be applied for the constant volume. Okay, now Cv is equal to Qv divided by delta T, where for the 1 gram So the CV is actually equal to what? Delta E divided by delta T. So for that purpose, for the 1 gram, m of gram, that is going to be what? Internal energy is going to be delta U is equal to mCV delta T. mCV delta T. Clear? Understanding? Understanding? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ delta U, that is internal energy, ಏನಾಗುತ್ತೆ mCV is equal to mCV delta T ಆಗುತ್ತೆ. ಈ ಯೂನಿಟ್ ಏನಾಗಬಹುದು? ಸೊ ನಮಗೆ ಗೊತ್ತಿದೆ ಆಲ್ರೆಡಿ, it is going to be the joules divided by kilogram. So that can be converted into the this. Clear? ಸೊ ಯಾವಾಗ ಏನೇನು ಆಗ್ತಿದೆ ಅನ್ನೋದು ನೋಡ್ಕೋಬೇಕು. ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಇತ್ತು, ಸೊ ವಿ ಹ್ಯಾಡ್ ಟೇಕನ್ ಇಟ್ ಹ್ಯಾಸ್ ವಾಟ್? ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಇತ್ತು, ಅದಕ್ಕೆ ಡೆಲ್ಟಾ ಎಚ್ ಡಿವೈಡೆಡ್ ಬೈ ಡೆಲ್ಟಾ ಟಿ ತಗೊಂಡ್ವಿ. ಸೊ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಇಟ್ ಹ್ಯಾಸ್ ಡೆಲ್ಟಾ ಇ ಡಿವೈಡೆಡ್ ಬೈ ಡೆಲ್ಟಾ ವಿ. ವೈ? ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್. ಓಕೆ, ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮು ಓಕೆ, ಇಲ್ಲಿ ಏನ್ ತಗೊಂಡಿದ್ವಿ? ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್. ಓಕೆ, done. Next, condition for molar heat capacity. So what is the condition for the molar heat capacity? C is equal to Q divided by delta T for 1 mole. So for that purpose, isothermal process, that is delta T is equal to also 0, constant. Yes, so for that purpose C is going to act like an infinity. C in act agutte, infinity act agutte, because delta T in the isothermal process nalli delta T is 0. For that purpose C will act infinity. Clear? So at equilibrium position means at constant pressure and temperature, if delta T is equal to 0, then C is going to be the infinity. C is going to be what? Infinity. Understanding how the conditions are going to work? Clear? How the conditions are going to work. Next comes the enthalpy. Before that, let's have a 5 minutes break. I will have some water and come, then I will continue it. Okay, let's have 5 minutes break. Ma'am, is organic chemistry completed? No, organic chemistry is not completed still. We are going according to one physical, one organic and all. Okay, Yes, I'm audible. Am I audible properly? Say yes in the chat box if I'm audible properly, guys. Let me also check once. So, ಇಲ್ಲಿ ತನಕ ಎಲ್ಲರಿಗೂ ತಿಳಿತಾ? ಇಲ್ಲಿ ತನಕ ಎಲ್ಲರಿಗೂ ತಿಳಿತಾ? Yes. Done? Let's start then. Next comes the enthalpy. So what is actually happening in the enthalpy? In thermodynamics, entropy, enthalpy are going to play a very important role. Okay, those are going to play a very important role. Let's go to the enthalpy and how it's actually been working. So enthalpy means, let us consider as H. Capital H is going to be considered as a enthalpy. ಎಲ್ಲೆಲ್ಲೂ ಹೋದ್ರೂ capital H ಅಂದ್ರೆ enthalpy ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು ಆಯ್ತಾ. Now mathematically it is heat contained in the system measured at constant pressure. At constant pressure, the sum of the internal energy and the pressure volume, that is PV energy, is known as the enthalpy. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ mathematically it is actually a heat contained in the system measured at constant temperature, measured at constant pressure. It's going to be measured at constant pressure. Concentrate properly, constant pressure anta helidare, constant pressure. So now what is going to be the sum? The sum of the internal energy and the pressure volume and the internal energy is going to be known as an enthalpy. It's going to be known as an enthalpy. Means what? H is equal to U plus PV. H is equal to what? U plus PV. Means internal energy plus the pressure into volume. Pressure into volume. Next comes what? It is impossible to determine the absolute value of enthalpy. It is impossible to Yes, it is impossible to determine the absolute value of enthalpy. So we determine the change in the enthalpy. So we are going to start determining the change of the enthalpy. That is going to be what? Delta H. Delta H. So where the delta H is equal to H final minus H initial. Okay. H final minus the H initial. Clear? So for that purpose, enthalpy is an extensive property because E and V are extensive properties. Enthalpy is an extensive property because E and V are going to be the extensive properties. E and V is going to be what? Extensive properties. Now enthalpy is it is a state function, and because E, P and V are the state function, it's going to be what? State function. In state function ide, enthalpy is always considered as a state function. Yadakandre H is always equal to U plus PV, and the change in the enthalpy is going to also be considered as delta U plus delta PV. Delta U plus delta PV. Clear? Next, when PV is equal, PV and T are variable, whenever the PV and T are variable at constant pressure, okay, at constant pressure, delta H is equal to delta U plus P delta V. It's going to be what? Delta H is equal to delta U plus P delta V. Done? So now at constant volume ಎಷ್ಟಾಗುತ್ತದು ಅದರ ಸಲುವಾಗಿ ಈಗ ಪ್ರೆಷರ್ ಆಯ್ತು, ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಅಲ್ಲಿ P ಬಂತಪ್ಪ. ಸೊ ಯಾವಾಗ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಆಗಿರುತ್ತಲ್ಲ ಅವಾಗ ಏನ್ ಬರುತ್ತೆ? ಡೆಲ್ಟಾ H is equal to delta U plus V delta P. It's going to be how much? V delta P. Clear? For the chemical reaction at constant temperature and pressure. So at a chemical reaction for the constant temperature and pressure. Understood? Understanding everyone? Understanding? If you have not marked your attendance, I am seeing that many people have not marked your attendance. Make sure to mark your attendance by hitting the like button. Fast like ಮಾಡಿ ನೋಡೋಣ. Come on. Fast like ಮಾಡಿ. Fast like ಮಾಡಿ ನೋಡೋಣ. Okay, let's move to the next part now. that is P delta V is equal to delta NGRT, that is delta NGRT, that is P delta V andre enta consider ಮಾಡ್ಕೋಬೇಕು delta NGRT, where so from the equation 1 delta H is equal to delta U plus delta NGRT. Clear? So delta U, that is P delta V andre ಏನು delta NGRT ಅಂತ consider ಮಾಡ್ಕೊಳ್ಳೋದು. Just you people need to replace the things, you just need to replace the things. So for that purpose, where delta H is equal to QP, where delta H is going to be the QP at constant P and delta U is equal to QV at constant V. Okay, delta V is equal to delta QV at constant V. So the equation is going to be equation 4, that is equation 4. Equation 4 ಏನಾಗುತ್ತೆ, that is can be also written as QP is equal to QV plus delta NGRT. So ಇದನ್ನ ಈ ತರಾನು ಬರ್ಕೋಬಹುದು, ಇದನ್ನ ಈ ತರಾನು ಬರ್ಕೋಬಹುದು. ತಿಳಿತಾ? So this equation is considered as fifth equation. This is considered as what? Fifth equation. Understood? ತಿಳಿತಿದ್ದೇನಾ ಎಲ್ಲರಿಗೂ? ಇವತ್ತು ಯಾಕೆ ಇಷ್ಟು ಮಬ್ಬಾಗ್ಬಿಟ್ಟಿದ್ದಾರೆ ಎಲ್ಲರೂ? Something is going on in your colleges? Mid term exam ಮುಗೀತು, ಯಾವಾಗ ಬರ್ತಿದ್ದೇನೆ FA? When FAs are coming, anyone have idea? Okay. Next comes the measurement of delta U and delta H calorimetry. So ಏನಾಗುತ್ತಪ್ಪ delta U measurements ನಲ್ಲಿ ಅದನ್ನ consider ಮಾಡ್ಕೊಳ್ಳೋಣ. So we'll make a points in this only and I'll make you explain. Okay. So for chemical reaction in a bomb calorimeter, so a chemical reaction in a bomb calorimeter, heat, whatever the heat is being observed at constant volume, is measured. At a constant volume is going to be measured. Clear? So here a steel vessel, that is the bomb, is being immersed in the water bath. Okay, a bomb is there, it has been immersed in the water bath. Theta water bath nalli a bomb, calorimetric bomb enidella adan measure madidare, means it has been dipped. Okay, here a steel vessel, a bomb is immersed in a water bath. So the whole device is called as calorimetry. Theta, if the calorimetry karitare, a bomb has been, not a bomb, atom bomb. So it's actually just a normal bomb. That bomb is being immersed into the whole, yes, it has been immersed into the water bath. It has been immersed into the water bath completely. Okay, and to ensure that no heat is lost to the surroundings. So to ensure what? No heat is being lost during the surrounding nalli enu lose agalla heat. Aita? So the combustible substances is burnt in the pure dioxygen supplied in the steel bomb. For that purpose, heat evolved. Okay, whatever the heat is getting evolved during the reaction is being transferred to the, it is get transferred to the water around the bomb. Theta. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ water around the bomb. ಕ್ಲಿಯರಾ? ಸೊ ಬಾಂಬ್ ಈಗ ಫುಲ್ ಹಾಟ್ ಇದೆ. ಕ್ಲಿಯರಾ? ಫುಲ್ ಬಾಂಬ್ ಹಾಟ್ ಇದೆ, ಅದು ನೀರಿನಲ್ಲಿ ಹಾಕಿದ್ವಿ, ಬಾತ್ ನಲ್ಲಿ ಹಾಕಿದ್ವಿ, ವಾಟರ್ ಬಾತ್ ನಲ್ಲಿ ಡಿಪ್ ಮಾಡಿದ್ವಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸರೌಂಡಿಂಗ್ ಇಸ್ ಕೂಲ್, ವಾಟರ್ ಇಸ್ ಕೂಲ್. ಇಟ್ಸ್ ವಾಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಹ್ಯಾಪನಿಂಗ್, ದ heat is being releasing there and the water is becoming warm. Clear? And its temperature is monitored. Since the bomb calorimeter is being sealed completely, it sealed idella completely, adakke ಏನು ಆಗ್ತಿದೆ inside ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. Okay, so its volume does not change, that is the energy changes associated with the reactions are measured at a constant volume. Under these conditions, no work is being done as the reaction is carried out at a constant volume in the bomb calorimeter. So in the bomb calorimeter, it's all things are happening inside the container. Inside the container ಆಗ್ತಿದ್ರೆ ಏನಾಗುತ್ತೆ, there will be no change in the volume. ಕ್ಲಿಯರಾ? ಸೊ ಏನಾದರೂ ಒಳಗಡೆ ಆಗ್ತಿದೆ ಯಾವ್ದಾದ್ರು ಸಿಸ್ಟಮ್ ನಲ್ಲಿ, ಇನ್ಸೈಡ್ ದ ಸಿಸ್ಟಮ್ ಇಟ್ಸ್ ಹ್ಯಾಪನಿಂಗ್, ಸೊ ದೇರ್ ವಿಲ್ ಬಿ ನೋ ಚೇಂಜ್ ಇನ್ ದ ವಾಲ್ಯೂಮ್. ಆಯ್ತಾ? ಫಸ್ಟ್ ಥಿಂಗ್ ಅದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತಾ? ಈಗ ಅಂಡರ್ ದಿಸ್ ಕಂಡೀಷನ್ಸ್ ಮೀನ್ಸ್ ವಾಟ್, ಅಂಡರ್ ದಿಸ್ ವಾಲ್ಯೂಮ್, ಅಂಡರ್ ದಿಸ್ ಸಿಸ್ಟಮ್ ಕಂಡೀಷನ್, ದೇರ್ ದ ವರ್ಕ್ ಇಸ್ ಬೀನ್ ಡನ್ ಹ್ಯಾಸ್ ದ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಕ್ಯಾರಿಡ್ ಔಟ್ ಅಟ್ ಅ ಕಾನ್ಸ್ಟಂಟ್ ವಾಲ್ಯೂಮ್. ಸೊ ಈಗ ಕಾನ್ಸ್ಟಂಟ್ ವಾಲ್ಯೂಮ್ ತಗೊಂಡು ಆ ಕ್ಯಾಲರಿಮೆಟ್ರಿಕ್ ಬಾಂಬ್ ಅನ್ನ ಹಾಕಿದ್ದಾರೆ ನೀರಿನಲ್ಲಿ, ಮೀನ್ಸ್ ವಾಟರ್ ಬಾತ್ ನಲ್ಲಿ ಹಾಕಿದ್ದಾರೆ. ಕ್ಲಿಯರಾ? ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ದ ಸಿಸ್ಟಮ್ system is working in a different way. Okay. So now even for the reaction involving the gases, there is no work done. So even then the reaction is been involving gases, there is no work done. That is delta V is equal to 0. Delta V is going to be 0 because volume is at the constant, guys. Constant volume idre ಏನು ಆಗ್ತಿದೆ ಏನು ಬಿಡ್ತಿದೆ ಏನು ಚೇಂಜಸ್ ಆಗಲ್ಲ. ಮಾಸ್ ಅಕಸ್ಮಾತ್ 1 kg ತಗೊಂಡಿದ್ರೆ ಮಾಸ್ ಅಷ್ಟೇ ಇರೋದು. There will not be any changes because it's closed container. It is having a constant volume. Simple. Clear? So ಇಲ್ಲಿ ಏನು ನೆನಪಿಟ್ಕೋಬೇಕಂದ್ರೆ ಕಂಡೀಷನ್ಸ್ ಅನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. ಯಾವ ತರ ಕಂಡೀಷನ್ಸ್ ಎಲ್ಲಿ ಆಗ್ತಿದೆ, ಹೇಗೆ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಏನು ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆನೋ, ಪ್ರೆಷರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ಅದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. ಆಯ್ತಾ? So the temperature change of the calorimeter produced by the completed reaction is then converted to the QV. It's converted to the QV by using the known heat capacity of the calorimeter. By heat capacity of the calorimeter. Clear? Heat capacity of the calorimeter. Next comes what? One second, guys. Yes, understanding? Next comes delta H measurements, means enthalpy measurements, how it's happening. Okay, how the enthalpy measurements are happening here. So here what happens is measurement for change in the heat at constant. Okay, whatever the measurements are happening at a heat, ಏನೇನ್ heat ತಗೊಂತಿದೇವಲ್ಲ at constant pressure ನಲ್ಲಿ, ಈಗ just ನಾವು constant volume ನಲ್ಲಿ ಏನು volume changes ಆಗಲ್ಲ ಅಂತ ತಿಳ್ಕೊಂಡ್ವಿ. ಸೇಮ್ ಅದೇ ತರ ಇಲ್ಲಿ if in case it's having a pressure has its constant and you're applying a heat to that. Okay, ಅವಾಗ ಏನಾಗುತ್ತೆ, generally under the atmospheric pressure it can be done in the calorimeter. It can be done in the form of a calorimeter itself. Previously ಹೇಗೆ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ತರ calorimeter ನಲ್ಲಿನೂ ಮಾಡ್ಕೋಬಹುದು. So we know that delta H is equal to QP at a constant P and therefore heat evolved or observed. Heat is actually evolved or it's going to be observed from the surrounding. That is going to be known as what? Heat of reaction, or it is also called as enthalpy of reaction. Oh, because the heat means ಏನು ನೀವು heat apply ಮಾಡಲಿ at constant temperature, sometimes it might exothermic process ಆಗ್ಬೋದು, sometimes endothermic ಆಗ್ಬೋದು. Means heat is getting released also, heat is getting observed also sometimes. Okay, so the delta RH, that is heat, is ಇದಕ್ಕೆ ಏನು ಕರೀತಾರೆ, delta RH ಅಂತ ಕರೀತಾರೆ. Okay, enthalpy of reaction change. Okay, this is also important. What is that? It's actually called as what? Enthalpy of reaction. Enthalpy of reaction. Clear? Heat is evolved for the exothermic reaction and the system will lose the heat to the surrounding. Clear? Heat has been evolved means what? Heat is getting released. Heat is getting released outside and the surrounding will observe the heat. Okay, in surrounding ಇದೆಲ್ಲ ಅದೆಲ್ಲ observe ಮಾಡುತ್ತೆ heat ಅನ್ನ, because heat is coming out, so it will be observed by them. So therefore QP will have a negative value and delta RH will also have a negative value. Similarly, heat is being observed for the endothermic reaction, that is QP is positive and delta RH will be the positive. Delta RH will be the positive. Clear? Next comes the entropy. Entropy means what? Degree of randomness or disorderness is known as entropy. Degree of randomness or randomness or disorderness is also called as what? Entropy. So now entropy change for the system is going to be work as what? Q divided by T. It's going to work with the Q divided by T. Clear? So let us learn it in detail right now, the entropy. Okay, now you people understood about the enthalpy. Let's learn about the entropy in a detailed way. Okay, so entropy nalli enagutte, S is actually lesser than the L and lesser than the gram. For that purpose entropy will start increasing. So this will start increasing. How it will start increasing? When it's coming from the solid. Okay, solid nalli idre kadame irutte, liquid hol takshana ಜಾಸ್ತಿ ಆಗುತ್ತೆ, liquid ಗಿಂತ ಜಾಸ್ತಿ ಗ್ಯಾಸ್ ನಲ್ಲಿ ಇರುತ್ತೆ. ಕ್ಲಿಯರಾ? liquid ಗಿಂತ ಜಾಸ್ತಿ gas ನಲ್ಲಿರುತ್ತೆ. Means what? Solid is lesser than the liquid, liquid is lesser than the gaseous. Clear? So on increasing temperature, volume, mole or molecule, dissociation or decomposition or vaporization, fusion entropy is increasing. So yellow enu irli, whether it is a dissociation, whether decomposition is happening or vaporization is happening, fusion of energy is going to happen. Fusion of energy is going to increase always. Okay, and increase agutte volume, fusion enthalpy ಹೇಗೆ increase ಆಗುತ್ತೆ, whether we are going to consider vaporization process, whether it is going to be a decomposition process, whatever the process is happening, there the increase of the fusion enthalpy is going to happen. Okay, fusion entropy is going to increase. Now on increasing the pressure, crystallization or bond formation or association entropy also decreases. So ಯಾವಾಗ increase ಆಗುತ್ತೆ, ಯಾವಾಗ entropy, dissociation, vaporization, ಡಿಕಂಪೋಸಿಷನ್ ಆಗುತ್ತಲ್ಲ ಅವಾಗೆಲ್ಲ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಯಾವಾಗ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಪ್ರೆಷರ್. ಯಾವಾಗ ನೀವು ಪ್ರೆಷರ್ ಅನ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಾ, ಕ್ರಿಸ್ಟಲೈಸೇಷನ್ ಅನ್ನ, or whether it is going to be the bond formation or association entropy, that time all it's going to start decreasing. Clear? So on mixing two solid or a two liquid or a two gaseous, non-reacting randomness increases. So non-reacting randomness also will increases. Clear? So for that purpose, mobility or randomness is directly proportional to, mobility or the randomness is directly proportional to 1 divided by molecular weight. 1 divided by molecular weight. Clear? So whatever the mobility we have taken or the randomness we have taken, that is actually directly proportional to the 1 divided by molecular weight. So next comes what? Before that you need to have two ideas about the entropy. ಯಾವಾಗ entropy increase ಆಗುತ್ತೆ, ಯಾವಾಗ entropy decrease ಆಗುತ್ತೆ ಅನ್ನೋದು. Okay, ಯಾವಾಗ increase ಆಗುತ್ತೆ, whenever the procedure of dissociation, decomposition, vaporization is happening, ಅವಾಗೆಲ್ಲ increase ಆಗುತ್ತೆ. Done. So ಯಾವಾಗ decrease ಆಗುತ್ತೆ, whenever increasing the pressure, crystallization, bond formation, association, so ಯಾವಾಗೆಲ್ಲ entropy decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ. Clear? Now, if molecular weight of the two species is same, then the more atomicity indicate more randomness. That is, H2 is going to be the greater than the N2, N2 is going to be the greater than the O2. Clear? Same, adhe tara next to unit of entropy. This is also important, guys. Okay, important. So what will be the unit? Joules divided by Kelvin, that will be converted as calories also divided by Kelvin. Okay, so depends on that. If you want to use joules, you can use the joules or you can use the calories. Next comes unit of the molar entropy. So molar entropy, just you need to add a mole to it. Okay, just you need to add a mole to it. Molar entropy will happen. If it is adding a enthalpy, then you can add a mole enthalpy. That will be mole enthalpy. Clear? Next comes entropy is an extensive property. Yes, entropy and enthalpy both are extensive properties. Okay, so molar entropy is an intensive properties. So molar entropy and molar enthalpy both are also going to be an intensive properties. Extensive properties bare entropy mate enthalpy, mate molar entropy mate molar enthalpy both are going to act like an intensive properties. Clear? It is a state function at equilibrium position or a reversible process at constant Pt. Delta S is going to act like a delta Vt. Okay, a delta S is going to act like in what? Delta H divided by T. Okay, delta H divided by T. Understood? So where the delta G is equal to delta H minus T delta S. So delta G is equal to delta H minus T delta S. T delta S. Clear? Understood? Now at equilibrium, delta G is equal to 0. So it is going to be what? 0 is equal to delta H minus T delta S. So adar salvagi illi substitute ಮಾಡ್ಕೊಳ್ಳೋದು, but Gibbs energy just substitute ಮಾಡ್ಕೊಳ್ಳೋದು. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, Gibbs energy ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತಿದೆ, that is internal energy also can be told as delta H minus T delta S. Theta. So ಇದು constant ಇರುತ್ತೆ. Okay, this is going to be the constant. So ಅದಕ್ಕೆ 0 ಹಾಕಿದ್ವಿ, ಇಲ್ಲಿ 0 ಹಾಕಿಬಿಟ್ರೆ, right? So delta H ಈ ಕಡೆ ತಗೊಂಡ್ವಿ, we brought this delta H this side, right? So delta H is equal to delta Ts. So we want to know the delta S right now. So delta S is equal to, so this T is going to come this side. So what will be that? Delta H divided by T is equal to delta S is equal to delta S. Now at equilibrium position, total entropy change is going to be the 0. So whatever the total entropy change is going to be the completely 0. So the delta S total is going to be 0. So the delta S system plus delta S surrounding is also going to be the 0 itself. Clear? Understood? Next, an ideal crystal has a perfect order of its constituents particles, while a real crystal has a less order because of some defects. Therefore, a real crystal has more entropy than the ideal crystal. Okay, real crystal kinta ideal crystal dali more ide, means it is having more. Next comes the second law of thermodynamics. Next comes what? Second law of thermodynamics. Then we have to learn about the Gibbs energy. Okay. Total entropy change is always positive for the universe. So whatever the total entropy you have taken it, that total entropy will change is always positive for the universe. It's always positive for the universe. Now for the spontaneous or irreversible process, total entropy change is always positive for a spontaneous or irreversible. Okay. Akasmat adu spontaneous ide, illadre irreversible ide. That process, the total entropy change is always going to act a positive way. Okay, always it's going to act a positive way. For that purpose, delta S system plus delta S surrounding is always greater than the 0. Delta S system and delta S surroundings is always greater than the 0. For that purpose, T1 is getting hotter. Okay, one vessel we are heating the product right now, right? So that heating the product, the heat will get transferred. That is delta Q is getting transferred or no. For that purpose, delta S, that is entropy, is going to be acting on the basis of delta Q and delta T. Okay, it's going to act on the delta Q also and it is going to act on the delta T also. Clear? So for that purpose, T2 is going to be the cold one. Clear? D2 is going to be the cold one. Next, entropy change for the different thermodynamic process. How the entropy is changing according to the different thermodynamic process. Fourth one. So starting nalli a fourth concept adu kalididave. Okay. Now maximum process are carried out in the open vessel, whereas show the expansion. So for according to the first law of thermodynamics, delta U is equal to Q minus W. So according to the first law of thermodynamics, we already know that delta is equal to Q minus W. But now Q is actually equal to Q, right? So that is going to be the T is equal to delta U plus W divided by T. Just substitute the things. Just substitute the things, right? Once you substitute, you are going to get that. Now next part what we are going to get is ds is equal to NCV dt divided by T and PdV divided by T according to the volume and according to the temperature. Okay, according to the volume and the temperature. For that purpose, ds is also equal to NCV dt divided by T, and that P is going to act like how? P is going to act like how? NRdV. NRdV. Simple. Substitute ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು ಎಲ್ಲ ಥಿಂಗ್ಸ್ ಅನ್ನ. ಓಕೆ, ಈಗ ಇನ್ ತನಕ ಏನೇನು ಕಲ್ತಿದ್ದೇವಲ್ಲ ಅವನ್ನೆಲ್ಲ ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. So the integrator for both the sides, integration ಹಾಕಿ ಎರಡು ಸೈಡ್ಗೆ equation ಮತ್ತು equation 2 ಗೆ what we are going to get delta, sorry, integration of 1 of 2 ds is equal to NCV is going to be the constant, so we are keeping it outside here. So divide integration of dt divided by T plus same nr ಹೊರಗಡೆ ತಗೊಂಡ್ವಿ, integration of dv divided by v. Clear? Integration of dv divided by v. Next, the delta S is equal to, once you integrate, you are going to get it as what? NCV, that is T1 of T2, ln of T1 of T2, ln of T1 and T2, same for the NR, ln of V, D1 and T2. Means integration just we converted into the ln form. We are going to convert into the ln. So what is going to be delta S? Delta S is going to act like NCV log E. NCV log E means this ln we are converting in log. Okay, so that T2 divided by T1 same ಅದೇ ತರ ಇಲ್ಲಿ log e V2 divided by V1. Done? Understood? So the delta S is equal to how much? How much it's going to act? 2.303 n CV log of T2 divided by T1. 2.303 n R log of V2 divided by V1. Clear? Important. Clear? Clear? Yes, Chini. Hi. Next comes the process and the constants and the value of entropy. Means what? It is easy to remember if you make the charts like this. Okay. ನೀವು ಯಾವಾಗ charts ಅನ್ನ ಹೀಗೆ ಮಾಡ್ತಾರಲ್ಲ, means in the form of a flow chart, or you people will make a boxes like this, it will be easy to understand. Okay, it will be easy to understand. Okay, so ಈಗ ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿದ್ದೇನೆ, processes ಯಾವ್ಯಾವ ಇದೆ ಅಂತ ನೋಡಿ. ಇಲ್ಲಿ isothermal process ಇದ್ದಾಗ T1 is always equal to T2. Okay, ಯಾವಾಗ isothermal process ಇರುತ್ತೆ ಅವಾಗೆಲ್ಲ T1 is always equal to T2. Okay, so ಏನಾಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಂಟ್ರೋಪಿ? ಡೆಲ್ಟಾ S is equal to 2.303 NR log of V2 divided by V1. Okay, ಯಾವಾಗ ಐಸೋಥರ್ಮಲ್ ಪ್ರೊಸೆಸ್ ಇದ್ದಾಗ ಈ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಇದ್ದಾಗ ಈ ತರ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಂಟ್ರೋಪಿ will be possible. That is the value of the entropy. Understanding? Next comes what? Isochoric process. Okay, isochoric process nalli volume constant irutte. V1 is always equal to V2. So that is going to be delta S is equal to 2.303 n VCV log of T2 divided by T1. Clear? The log of T2 divided by T1. So same isobaric process nalli enagutte pressure constant irutte. Pressure constant iddaga delta S is equal to 2.303 NCP log of T2 divided by T1. So next comes the adiabatic process where the heat is going to completely be 0. So delta S is also going to be the 0. Means what? In this way, if you people make the box, okay, isothermal ಏನಾಗ್ತಿದೆ, isochoric ನಲ್ಲಿ ಐಸೋಬಾರಿಕ್ ಪ್ರೊಸೆಸ್ ನಲ್ಲಿ ಅಡಿಯಾಬೆಟಿಕ್ ನಲ್ಲಿ ಏನೇನು ಆಗ್ತಿದೆ ಅಲ್ಲ ಅದರ ಪ್ರಕಾರ ನೀವು ಅದನ್ನ ಬಾಕ್ಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು. ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಏನಿದೆ ಅಪ್ಪ, ಈ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ ಯಾವ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. ಸೊ ಈ ತರ ಮಾಡಿದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಈಸಿ ಟು ಮೇಕ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ಈಸಿಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ತಿಳಿದಾ? Next comes the spontaneous process. Okay, we have a spontaneous, then we have a Gibbs free energy, then we will be learning about third law of thermodynamics. Okay, so spontaneous process nalli enagutte, the process in which the physical and the chemical change occur due to its own means without any external help. Clear? So enagutte process, so the process in which physical and chemical change is possible occurring due to the own method. Okay, due to its own means without any external help. Okay, without taking any external help, the process where actually the physical and the chemical properties are getting changed. Okay, isobaric process. Okay, the process where the physical and the chemical change occur due to its own means without any external help. External help indane change aguttide. Clear? So spontaneous process is irreversible. So once a product form adre a product to reaction nalli form agalla. Next comes the Gibbs free energy. Gibbs free energy. So in Gibbs free energy, wherever the energy is being obtained from a system which can be put into the useful work mean. Okay, LL energy is obtained agiruttalla in the form of a system. Okay, energy has been obtained in the form of a system which can be put into the useful work. Okay, useful work ne convert ಮಾಡ್ತಿದ್ದೇವೆ. Clear? Useful work ಗೆ convert ಮಾಡ್ತಿದ್ದೇವೆ. Example Darsha. ಯಾವ example appa? So there the delta G is equal to what? W, that is going to be the useful one. Clear? So the according to the first law of thermodynamics, delta U is equal to Q plus W. Delta U is equal to Q plus W. Clear? Here W includes two types of work, that is thermodynamic work, that is P delta V, and useful work, that is workful. Okay, workful. Understanding? Come on. Yes, very good. ಸಿಗ್ತೈತಾ ಗಿಬ್ಸ್ ಫ್ರೀ ಎನರ್ಜಿ ಅಂದ್ರೆ ಏನು? ಯಾವಾಗ ಎನರ್ಜಿ ಇಸ್ ಬೀನ್ obtained in a system, it's a energy in the obtained in a system. Spontaneous reaction example spontaneous reaction irreversible process ಅಂದ್ರೆ ಏನು ತಗೋಬೋದಪ್ಪ? anything you can take. Irreversible process ಇದು, okay, can't be converted again. Next comes here, W includes two types of work, thermodynamic work and one more is useful work. Next comes the example of the useful work. ಯಾವ ತರ examples ಇದೆ useful work ಮಾಡ್ಲಿಕ್ಕೆ, clear? So ಇಲ್ಲಿ H2O which is forming H2 plus half O2. H2O is which is getting converted to H2 plus half O2. What is happening here? KClO3 where the KCl plus 3 by 2 O2 is forming in the form of gaseous itself. Okay, same ಅದೇ ತರ calcium carbonate ಇದು ಕೊಟ್ಟಿದ್ದಾರೆ. You can go through this all three examples. Easy ಆಗುತ್ತೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಯೂಸ್ಫುಲ್ ವರ್ಕಿಗೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ ಇನ್ ಅಬೌವ್ ರಿಯಾಕ್ಷನ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ವರ್ಕ್ ಆರ್ ಬೀನ್ present, that is thermodynamic work due to expansion of gases, next is useful work to dissociate the compound, next comes the galvanic cell reaction is spontaneous, so obtained free energy is converted into the useful work. So in galvanic cell free energy is converted into the useful work. Yes, very good Chini. So your free work is actually getting converted into the useful work. Free work ಏನೇನಿದೆ ಅಲ್ಲ ಅದೆಲ್ಲ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಯಾದಕ್ಕೆ? it will be converted to the useful work. For that purpose delta G is equal to W useful is equal to E select, that is going to be minus NF E naught, for the Gibbs free energy. Next comes C diamond is getting converted into the C graphite. So ಯಾವಾಗ diamond ಮತ್ತೆ graphite convert ಆಗ್ತಿದೆ, okay, ಏನಾಗುತ್ತೆ ಅವಾಗ delta G is actually equal to the W useful, means what is getting useful, that is P delta V, that will be what? P delta V. Here to convert one allotropic form to another, free energy change is equal to useful work. Okay, ಯಾವಾಗ conversion ಆಗ್ತಿದೆ one entropy ದಿಂದ another entropy ಒಳಗಡೆ ಅವಾಗ free energy changes is very much useful. Okay, ಯಾಕಂದ್ರೆ ಫ್ರೀ ಆಗಿ ಎನರ್ಜಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅಲ್ಲಿ ಎಂಟ್ರೋಪಿ ಅಂತೂ ಚೇಂಜ್ ಆಗ್ತಿದೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ದಟ್ ಇವನ್ ದ ಫ್ರೀ ಎನರ್ಜಿ ಇಸ್ ಆಲ್ಸೋ ಯೂಸಿಂಗ್, ಇಟ್ಸ್ ಬೆನಿಫಿಷಿಯಲ್, ರೈಟ್? ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಅವಾಗೆಲ್ಲ ಏನಾಗುತ್ತೆ, ಮ್ಯಾಥಮೆಟಿಕಲಿ ಫ್ರೀ ಎನರ್ಜಿ ಇಸ್ ದ ಡಿಫರೆನ್ಸ್ ಆಫ್ ದ ಎಂಥಾಲ್ಪಿ ಅಂಡ್ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಟೆಂಪರೇಚರ್ ಅಂಡ್ ದ ಎಂಟ್ರೋಪಿ. ಕ್ಲಿಯರ್? So here G is equal to H minus Ts, where the G, that is internal energy plus PV minus Ts. Clear? Now it is impossible to calculate the absolute value for the free energy because it is not possible to calculate the absolute value of the enthalpy of a internal energy. Why? Because calculation of that absolute value for the free energy is impossible only. Why? Because we can't only. Okay, ಏನೇನು ಫ್ರೀ ಎನರ್ಜಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾರೆ, ಎಲ್ಲಿಂದ ಎನರ್ಜಿ ಆಕ್ಚುಲಿ ಬರ್ತಿದೆ ರಿಯಾಕ್ಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗ್ಲಿಕ್ಕೆ, ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ಐಡಿಯಾ ಓನ್ಲಿ. ಓಕೆ, ಈಗ ಅಕಸ್ಮಾತ್ H2 ಇಸ್ ಗೆಟಿಂಗ್ ರಿಯಾಕ್ಟೆಡ್ ವಿತ್ ಆಕ್ಸಿಜನ್ ಟು ಫಾರ್ಮ್ H2O ಅಂತ ರಿಯಾಕ್ಷನ್ ಇದೆ. ಓಕೆ, ಆ ರಿಯಾಕ್ಷನ್ಗೆ ಆಗ್ಲಿಕ್ಕೆ ಟೆಂಪರೇಚರ್ ಯೂಸ್ಫುಲ್ ಆಗಿರುತ್ತೆ, ಪ್ರೆಷರು ಇರುತ್ತೆ, ಬಟ್ ಎಲ್ಲಿಂದ ಬರ್ತಿದೆ ಅನ್ನೋದು ನಮಗೂ ಗೊತ್ತಿಲ್ಲ, right? So if you are doing it in a laboratory you will have an idea, but naturally, absolutely naturally in a open system ಹೇಗಾಗ್ತಿದೆ ಅನ್ನೋದು ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ಯಾವ ತರ ಎನರ್ಜಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅನ್ನೋದು ಯಾರಿಗೂ ಗೊತ್ತಾಗಲ್ಲ. that's what it's actually impossible to create it. Clear? Next comes at constant PT. At constant PT means at constant pressure and temperature, delta U is equal to delta U plus P delta V minus T delta S. That is delta U plus P delta V minus T delta S. So delta G is equal to delta H minus T delta S for system. So in a standard condition, NP is equal to, standard condition, pressure is equal to 1 atm. Pressure ಎಷ್ಟು ಹಚ್ಚಿದ್ದಾರೆ? 1 atm pressure ಹಾಕಿದ್ದಾರೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಟೆಂಪರೇಚರ್ is going to be 25 degrees Celsius or it also 298 Kelvin. Okay, so the delta G naught is going to be what? Change in Gibbs energy is equal to change in H minus T delta S naught, minus T delta S naught. So the free energy is an extensive property. Free energy is an extensive property, and free energy is a state function. Free energy is also a state function, and the free energy change for a reversible reaction is going to be what? Delta G is equal to delta G naught F plus 2.303 RT log Q. Okay, ಏನೇನ್ ಚೇಂಜ್ ಆಗ್ತಿದೆ ಅಲ್ಲ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಡೆಲ್ಟಾ ಎಚ್ ನಾಟ್ ಟಿ ಡೆಲ್ಟಾ ಎಸ್ ನಾಟ್ ಅವ್ರದ್ದೆಲ್ಲ ಈ ತರ ಬರ್ಕೋಬಹುದು ವೆನ್ ಇಟ್ ಇಸ್ ಇನ್ ದ ಫ್ರೀ ಎನರ್ಜಿ. ಓಕೆ, ವೆನ್ ಇಟ್ ಇಸ್ ಇನ್ ದ ಫ್ರೀ ಎನರ್ಜಿ. Anything you can take, Amma. You can keep it in the Kelvin also. You can keep it in the degree Celsius also. Okay, no problem. Both are same only. If they have mentioned something like that, then you need to depends on that. Next comes the how it is going to be delta H andre negative irutte, delta S is going to be the positive, delta G is negative, then it is a spontaneous. Yav process? If in case delta H is going to be the negative, delta S positive ide, delta G negative ide, spontaneous anta karitare. It's going to be the spontaneous reaction. Clear? Okay, in the formula. What in formula pa? Should we put a temperature in the Kelvin or degree? You can put anything. Usually they will put it in the Kelvin itself. Okay. Positive. If delta H positive idre, delta S negative idre, delta G no positive idre, it's going to be the non-spontaneous. Clear? So in a simple way, delta G is negative, spontaneous. Delta G is positive, non-spontaneous. Done? Next comes what? Negative, negative. Delta H negative is there, delta S negative is there. Then the high temperature, then its delta G is also going to be positive. Whether if it is going to be the high temperature idre, ashte delta G will be positive. Okay, that time it will be non-spontaneous and spontaneous reaction. Clear? So delta H is positive, delta S is also going to be positive, then delta G is low temperature. Delta G is going to be the low temperature, then it's going to be the spontaneous and non-spontaneous. Clear? Low temperature of delta G will be the negative, high temperature of delta G is going to be the positive. Clear? So ನೋಡಿ ಇದು ಬಾಕ್ಸ್ ಅಷ್ಟೇ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರು ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವ ಪ್ರೊಸೆಸ್ ಅನ್ನೋದು. ತಿಳಿತಾ? Which is that process? Easily you can get it. Right? Yes, right, correct. Next, if temperature is more than the equilibrium temperature, then it is known as high temperature, and if the temperature is less than the equilibrium temperature, then it's known as a low temperature. Clear? Simple? Clear like a water, ma'am. Yes, very good. Clear like a water, huh? Okay. Next comes what? Third law of thermodynamics. This is the last concept. We will learn its limitations also. Okay. What is the third law of thermodynamics says? Entropy of a pure crystalline substances is zero at absolute zero temperature. At absolute zero temperature. If you have not marked your attendance, fast mark ಮಾಡಿ ಎಲ್ಲರೂ. Let's see how many people are going to like it. Fast agi. ಲೈಕ್ ಮಾಡಿ, ಫಾಸ್ಟ್ ಆಗಿ ಲೈಕ್ ಮಾಡಬೇಕು. ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಬೇಕು ಯಾವ ತರ ಕ್ಲಾಸಸ್ ನಡೀತಿದೆ, ಹೌ ಮಚ್ ಇಟ್ಸ್ ಯೂಸ್ಫುಲ್ ಟು ಯು ಪೀಪಲ್. ಯು ನೀಡ್ ಟು ಶೇರ್ ಇಟ್ ವಿತ್ ಯುವರ್ ಫ್ರೆಂಡ್ಸ್ ಆಲ್ಸೋ. ಕ್ಲಿಯರ್? Yes, third law of thermodynamics, where the entropy of the pure substances is zero at absolute zero temperature. Okay, entropy of a pure crystalline substances is zero at zero temperature. So the information about the entropy is given by slot, that is second law of thermodynamics. Information about the entropy is given by second law of thermodynamics, while it is calculated by the third law of thermodynamics. Okay, second law of thermodynamics entropy ಬಗ್ಗೆ ಹೇಳುತ್ತೆ information, but calculation will be done by it is done actually by the third law of thermodynamics. It's done now. Make sure you'll share with your friends also, so that they will also like the thing. Okay, like the video, and they'll have an idea that the classes are going on. They can use it. Okay, so what it tells now, here you can just observe temperature is 0 Kelvin, S is going to be the 0. Whenever the increasing the temperature, T is going to increase, then the 0 Kelvin, S is going to increase 0 Kelvin. But what is happening with the molecules? You can check it. Okay, what is actually happening in the molecules? Here the molecules are tightly packed. When you apply a temperature, it will start jumping. Means what? ಈಗ ನನಗೆ ಯಾರಾದರೂ ಯಾರಾದರೂ ಏನಾದರೂ ಟೆಂಪರೇಚರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು, ಇಲ್ಲ ಬೈಲಿಕತ್ರು ಯಾರಾದರೂ ನನಗೆ, ನಾನು ಏನು ಮಾಡ್ತೇನೆ? ಐ ವಿಲ್ ಬಿಕಮ್ ವೆರಿ anxious and I will go and shout them very loudly. Means what? The time my blood will be boiling out, right? The blood will be boiling out. Same ಅದೇ ತರ ಇಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ the molecules will be running everywhere. Okay, next imitations ಏನು third law ದು mixture of isotopes do not show zero entropy at absolute zero temperature. So whatever the mixture of isotopes are there, that will not show a zero entropy at absolute zero temperature, at a absolute zero temperature. So ಯಾವ್ಯಾವ್ದು mixture ಇದೆ ಅಲ್ಲ, whichever the mixture is present, actually that mixture of the isotope will not show, they will do not show the zero entropy at absolute temperature, at absolute temperature. Clear? So next comes the glassy solids such as CO, CO2, NO, N2O or NO2, H2O, etc. does not show zero entropy at absolute zero temperature. Clear? So whatever the glossy solids such as CO ಇದೆ, ಇಲ್ಲ CO2 or NO or N2O, NO2, H2O, etc. that does not show the zero entropy at absolute zero temperature. Clear? So these are the limitations of a third law of thermodynamics. Clear? So first law of thermodynamics is explained about the enthalpy to us. Okay, first law of thermodynamics enthalpy ಬಗ್ಗೆ explain ಮಾಡಿತು. So ಈಗ enthalpy ನಲ್ಲಿ whether the delta G, internal energy, delta S ಯಾವಾಗ negative ಇರುತ್ತೆ, that time it will be a spontaneous or a non-spontaneous. That is very important. Clear? So ಅದಾದ ತಕ್ಷಣ we studied about the second law of thermodynamics. Okay, ಆ second law of thermodynamics ನಲ್ಲಿನೂ ಏನ್ ಕಲ್ತ್ವಿ? main thing second law ಅಲ್ಲಿ we learnt about the entropy. But what we learned actually about the entropy, how actually it's working out, that we learnt. But the calculation, everything will be done by a third law of thermodynamics. Clear? So this is all about the thermodynamic chapter. Okay, thermodynamic chapter. So this thermodynamic chapter is actually important in the perspective of NEET. ನಾ NEET ನಲ್ಲಿ ಏನೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ ಅಲ್ಲ ಅವನ್ನೆಲ್ಲ ಹೇಳಿದ್ದೇನೆ ಇಲ್ಲಿ. ಈವನ್ ದ PU board students can also refer it because I have taken all the notes also properly according to the NCERT also. So they can also refer this classes for the purpose of PU board also and for the NEET also. NEET ಗೆ ಯಾವ್ಯಾವ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಅಲ್ಲ and point wise ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೇನೆ. So next class we will be learning about the PYQs also. We will do the PYQs separately according to the lessons, whatever the theory I have explained, according to that PYQs also will learn. Okay, so first you make sure that you will be perfect with the theories so that we'll solve easily the PYQs. Okay, clear? Okay then, see you in the next class. Bye bye.